Yes.
Once you use a string,
Yeah.
one string, one string, right?
Yeah.
Okay. Then I will say why in the string. Each
Yeah.
character.
Each
Oh, okay. Because I was thinking of one string. So
No.
I was thinking about
If it's a number, then it's one number, but if it's a string, it has 3 characters in it. You loop over it, you get 1 character at a time.
Okay.
That's what we're doing here.
Okay, I see. Yeah, because I think now I'm sorry this way because I thought it's only if you have multiple strings, right? You can use one string at a time. Each time.
No, it's 1 character at a time.
Okay.
Yeah.
I see.
Yeah, she was. Oh, sorry. What was your question?
So this is the one where you look at the middle.
Remove a decent number. Okay.
That is actually
Yeah, it does not happen next. Yeah. Yeah, thank you. Maybe talk to you about the class. Okay, I come back later. Yeah. I'll have a break about 30 minutes, 12 to 12:30-ish. But I might step out during that time quickly to get some maybe after the class. Class will end at 4 o'clock. Yeah. Okay. So remove adjacent number, it says has no value next. Where is next? Well, that's
Recording is going on.
Yeah.
Yeah, right here.
Oh, yeah, sorry. Yeah, I got next. And it's a string. I use a string. And it's saying there's no next. What does next give you? Element in a list.
Yeah.
But if it's a string, and I use a string, you can't do next, is what it's saying.
Why not? You can only do it on numbers.
You can only do it on lists.
Right, but it's I didn't print it, but it's the same as the previous one. The list is a list of strings. Each element
Each element is a string.
is a string of one person.
I'll have to report. But I think when you say something got next, you have to give it. I forget what next does. You have to give it the iterator, not the element. Element is a string. The iterator is your list. So
you have to go next in your user list?
yes, something like that. There was one question, and then we'll go. I'll start the class in just a minute.
Actually, I got it.
You got it?
Yeah, I got it.
Okay, good.
But then for the button,
Uh-huh.
I have to do the same thing with the action transfer. Inside the transfer. So to whatever.
What's the question? For another button. Okay.
So by the way, this source will already recognize all the patterns.
Source is just a path. This is just a string. This is just a string. What do you mean recognize all the path in there?
So this is like this.
What's your question? I know that's what you want to do, but what's your question to me? So what I would do is put another button, and when users click that button, you have to copy the content from here to here, right? So when the user's copying, then you call it, you say sh_copy. So the dot copy will require 2 arguments. The first argument is that, second argument is that. Right? Yeah. So let's start today. So I think last week when we met, we didn't complete all the slides, so maybe I'll do that first. So one thing I learned, the reason classroom is getting very hot in the afternoons is because the door is not closed. When the door is not closed, air conditioner shuts off.
No.
So should we keep it closed? So by the time you can still walk in and walk out.
So you were short circuiting the air
Yes. I wish they put a little label there, please keep the door closed.
conditioner. Close for air conditioning.
All right, so let's just take a quick review of what we did. Excuse me, are you going to start that video?
Yeah, it's on.
It's on. Okay, good, thank you. So let's take a quick review of what we learned so far. Right. So this is week number 3. In the first week, we learned about lists, right? One of the data types. In the second week, we talked about strings and I think our strings maybe half and half, and then dictionaries. So lists, strings, and dictionaries. Each of these 3 are probably the most important data types in Python, and we talked about some of the methods that you can operate use on each of these data types, right? And then last week, towards the end of last week, I started the next portion, which is the so these are all strings, and then strings, and then strings, and then dictionaries here. And then I think we talked about control structures, loops, if-else statements, for loop, while loop. Notice that each of these has an else condition. Not often used, but it's useful. Range methods, there's a bunch of these control structures available. So somewhere around here we stopped. Did we talk about list comprehension? Do you recall?
No, still not covered.
So let's go back a few. I think we talked about break and continue statements, correct? Yep. So maybe we'll start from there. So looping with multiple entries. So this is basically the same. So look at this slide. Look at this slide. This is basically, what is this data type?
List of tuples.
It's a list of tuples. The moment you see a square brackets, you know it's a list. And the moment you see parentheses, it's a tuple. The sister of lists, basically. Similar properties. The only thing is tuples are immutable, whereas lists are mutable. Lists are mutable means you can add a element to it, remove an element, and so forth. With tuples, you cannot do that. In other words, they are immutable.
What would you have like 2 different data types that are very similar with like some minor differences?
Why we have them?
Yeah.
I don't know. Sometimes I think lists offer flexibility, right? Because you can modify them. But it comes with a. My guess is it comes. It's a guess, but I'm not sure. It comes with a performance cost. Whereas if you eliminate the ability to be mutable, then performance is better.
And the memory consumption, I believe, right?
What's that?
The tuples will consume less memory because
Yeah.
it's fixed. There's only one pointer.
Yeah.
With the list, you have to keep.
Right. Performance. Yeah.
And
It's not.
So it's working.
Yeah.
Okay. I hope you don't shiver today.
If it's too cold, you know how to fix it.
Yes. Yes.
We can adjust numbers.
All right. So list of tuples, right? So normally, if you want to iterate over it, we'll do like this, right? You say for t in that list, some list, and then you will do something inside. And for t would be first time around t would be this, second time around t would be this, the third iteration t would be this, right? And each time t is a tuple, right? But if you want to access the first element of that tuple or the second element of that tuple, you say t of 0 or t of 1, right? So this is one way to loop. What I'm saying in this slide is there's another way also to do the same thing. Instead of saying for t in some list, I can say for t for x comma y in some list. Normally I would put x comma y in parentheses, but you can eliminate those, you can skip those as well. So for x comma y in some list, now first time around, x is 1 and y is 2. Second time around, x is this and y is that. Third time around, that. So instead of t of 0 and t of 1, you can just say x and y. And sometimes if there is 3 elements, you can say x, y, and z also, and so forth. Just another way to access individual elements inside that list. Looping with multiple entries. So instead of looping over with a single entry, like you do here, the iterating variable is t, you can do it with multiples, with x and y, or more. Okay, so there is that flexibility as well. So let's keep going. There's another method called enumerate function. It's applied to lists and it returns tuples of index and item. For example, you have an enumerate 1, 4, 3, 12. It's a list, right? As you can see, the argument to the enumerate method is a list. What this will give you is a list of tuples like this. It actually gives you an enumerate object, but if you convert that into a list, you get this. The first element of each tuple, like 0, 1, 2, 3, those are the indices. It's indices. And the second element in each tuple, 1, 4, 3, 12, are the actual values of that list. So in other words, if I convert a list into an enumerate object, I have basically both the indices as well as the values all in the same list. Sometimes this may be handy if you want to iterate over. If you normally use a for loop, right, on a list, you only iterate over the values. And if you are a person who has programmed in other languages like C or C++, where when you iterate over a list or an array or something, you actually are iterating over the index, not the value. Whereas in Python, you're iterating over the value. And sometimes you feel the need, hey, I need the index too, not only the value. What you are probably doing is you are keeping your own counter and incrementing it by 1 each time you look through the list. Right? Here, if you do this way, if you instead of iterating over a list, if you iterate over the enumerate object of that list, then you don't need to create your own counter to keep track of the index. You have that right here in the first element as every tuple. So just another object, just another facility.
So is that a shorthand version of the one from the previous slide? When you take out the first number in each of the pairs there?
Of the previous slide?
Yeah, so like when you have that sum list where you have the 1 and 2 and 3.
Yeah, yeah.
That's the full notation. The other way is a shorthand notation of the same thing.
No. This is a list of tuples, and what is inside each tuple can be anything. Here I have 2 elements, you can have 3 elements, you can have 5 elements in each tuple. It's just a list of tuples. In this example, I chose 2 elements. That's right. Okay. But you can have more. Whereas here, I'm showing you how to convert, in some sense, list into a list of tuples.
Is that different than the previous one? I thought you said the previous one was also a list of tuples.
It is also a list of tuples. This is also a list of tuples. That's your question. Yes.
Okay. So how is the bottom one different from the one that says 0?
right here.
Yeah.
So this one I'm converting that enumerate object into a list. If you recall, the range object we talked about, like the range of. So basically, maybe that may confuse. So this enumerate gives you an enumerate object. It's another data type, almost, right? But you can convert that into a list, so you can visually see how it looks. So the first element is always the index of that element in that list, and the second element is the actual element. So 1, 4, 3, 12 are the second elements, and the first elements are 0, 1, 2, 3, the indices.
How come you convert to a list of 2 items with it? How come not 3 or 4?
Well, in this case, you can only have the index and its value.
Okay.
So only 2 things.
Index and what?
Value.
Value.
So 1, 4, 3, 12, these are the values.
Okay.
And the indices are 0, 1, 2, 3.
Right.
So in enumerate will only have 2 elements in each tuple.
So it default automatically have 2 elements?
Yes.
Can you set it 3 or 4?
I mean, you can build a list of tuples that are more than 2 elements. For example, if I said x equal to 1, 5, 1, x equal to 2, 7, 9, 4, 3, 21, 44, 7, 3, 5, 7, 9, whatever, right? So this is a list of tuples, and each tuple is 4 elements in length. Right? And this is fine, this is legal, you can do this. All I'm saying, yeah, that's fine. But when you use enumerate object to convert a list into a list of tuples, you will only have 2 elements in each tuple. And the first element is the index, the second element is the value. But a list of tuples is more generic. You like we have X here. You can have 4 elements, 7 elements, or how many ever you want.
So when you do the enumeration, even though we're only seeing the values, the indexes are still there because the same order.
You are seeing the indexes too, right?
Yeah, that way. But I mean, the shortened line, the one that says enumerate, you don't
Right
see
here.
the index.
You don't see index, you don't see the value either. When it's an object, it's like that's where I was going with range object. For example, if I said range of 5, I'll give you, or if I say a equal to range of 5, how do I get that to print that memory? So anyway, but if I convert it to list, then I get 0, 1, 2, 3, 4, right? Same thing here for enumerate. So enumerate 1, 3, whatever. It give you, it's an object basically. It's like it'll give you, normally when you try to return that, you get a memory address, and that's how Python prints it in this shell. But if you convert that into a list, for example, if I said A is my enumerate or Q is my enumerate object, if I said list of Q, then I converted that enumerate object into a list. The benefit of keeping it as an enumerate object is it occupies less memory because but if you convert it to a list, it occupies more memory because it has to save up everything. Normally, we would use the enumerate objects in a loop. Yes.
Can you create a list out of the enumerate object all in one line? You go list, parentheses, enumerate.
Yeah. I mean,
Value.
like here I'm creating an enumerate object, right? I can just throw out a list in front.
Okay.
And now my Q is not an enumerate object. My Q is now a list, or a list of tuples.
So when you add the list there, what it does is it adds the indexes?
It converts the enumerate object into a list.
Converts it into a list, and converting it into a list is
know, enumerate object itself has all the indices. You just visually see it. The benefit of, like, let me go back to range object. Remember, I was telling you, if you say range of 5 or range of 5 million, they both occupy the same amount of memory. Right? Range of 5 has what? 0, 1, 2, 3, 4, right? Range of 5 million has what? 0, 1, 2, 3, 4, all the way to 5 million. But they both occupy the same amount of memory in your
5 million minus 1.
Yeah, 5 million minus 1. Why is that? How is 5 million to do that? Whereas this only has 5 elements, this one has 5 million elements, and yet both have the same amount of memory. That's because it's not storing all the 5 million elements in your memory at the same time. It's just keeping it as a range object. But if you loop over, when you loop over, typically these objects, enumerate or range, are used as in a loop to iterate over it. So when you loop over it, it gives you the next element in that list. First it will give you 0, then it will give you 1, then it will give you 2, all the way to 5 million. That way, it doesn't have to store all the 5 millions in one place. Now, if you convert this into a list, if you say a list of range of 5 million, then you're forcing Python to put all the 5 million elements in your memory because it wants to, you need to be able to see all that, like when you print it like this, or whatever you want to do with it. You want to take the 22 millionth element and add 3 to it, or whatever it is you want to do. So the more converting it into a list will consume more memory. Same thing here, right? And same thing for enumerate object also. It's already has both index and the element. You're just not seeing it. But when you, or if you iterate over it, you will get it. But if you convert it into a list, then it's showing you everything all at once.
What if you do enumerate by itself? And if somebody doesn't want to change it to a list?
Oh, you don't need to send it to a list. You can still use enumerate object in a for loop, for example. You can say for I comma j in enumerate of a or something, right? 1, 4, 3, 12. And then you can do whatever you want to do with it. You don't have to convert it into a list.
But I need to mention indices of here of I and j both.
I and j will be your, I will be the index, j will be your value. Yeah.
So I cannot iterate over only the j or I.
You cannot iterate, you can iterate with one element, like t. And then you inside your code, if you want index, you will use t of 0. If you want the value, you will use t of 1. Just like I showed in the previous slide. But essentially, you're not converting it into a list. You don't have to. For loop is not just for lists. For loop is for enumerate objects also, or range objects, or many other types. Right? So in this case,
Is that for performance and efficiency, people always use it as an object and never convert it to a list?
yeah, it's usually a good idea, especially if this number, if this data that you're passing in is very, very large, like 5 million, for example, or in a range. Same argument applies for range also. Then if you convert everything into a list, then you're putting more memory on the computer. For small lists, it doesn't matter, because the computers are very big. But if you're dealing with large data, or if you're dealing on a smaller processors, where memory and processing power is at a premium, then you want to watch out for all these little things. You don't unnecessarily convert into another data type, which will take more memory. So this is an option for you to convert a list into a list of tuples, and the benefit is you now have a value that represents the index, first one, and the second one that represents the actual value. Can you convert a list to enumerate? That's what we just did here. Right? We converted a list to an enumerate. Your question the opposite. Convert a list of tuples back into a list. You can. I can't think of a method to do that. But essentially, what you're asking is if you have a list of tuples, 1, 3, 7, 5, 3, 14, essentially what you're asking is give me the second element of each tuple. That's what you're asking, right? There's no one method to do that, but you can quickly write something, right? So if this were x, you can say for I comma j in x, my new list is append to 0, L dot append of j, and print L. So each tuple you're taking the second element, stuffing it into a new list, and that list is your answer. So it's not, I mean, even this one, if you have to build an object, you can do that, right? Converting a list to a list of tuples. That's not difficult at all. You write a for loop to do that. The benefit of an enumerate object again is you can stuff a lot of memory. It doesn't save all the elements. Let's say it's a 4 element, it has 5 million elements, then performance-wise it's still just as good. That's where. Whereas if you write your loop, it has to take a lot of runtime to compute something like this.
It is converting into list memory, not literally.
No, it's not converting into. When you use the list method to convert, then it is. But when you just create an enumerate object here, it is not putting all the elements in the memory. It just knows it's an enumerate object. So that the benefit comes in a for loop where you don't need all the 5 million elements at once, but you only need one element at a time. In such cases, it knows what it gave you last time in the for loop, so it will give you the next element in the for loop. But you don't ever need all the 5 million elements in one time.
So when you say for I, J in enumerate, so what does I
points to the first element,
or the
J
index?
points to the second element.
So index under I.
Yeah. So going back, this is the style I was using there. For x comma y in some list, you can use that, right? Here's a little example. Let me skip over it. Or maybe I can quickly explain. So if x were that, I'm saying for I comma n in enumerate of x, and then do something. So I will be referring to the index of this element, and n will be referring to the value of each of these, right? So, and then I'm doing something with it. If n is less than 0, then I'm printing the index. So this is one simple example. Next one is zip method. You zip to a list equal 1, 2, 3, 4 and y equal ABC. And I say z equal to zip of x comma y. Z will be basically 1a, 2b, 3c. And 4 doesn't have an equivalent element y. So you're limited to 3 elements in the zip. So again, this is a list of tuples. It's a list, you see it's a square bracket, and you see parentheses, it's a tuple. So it's a way to combine two lists into one. Not concatenate them. If you want to concatenate them, you just use plus, right? A plus B will give you a longer list. Here you're zipping them up. So you are building tuples of each of these.
But these are both elements, right? 1A, 2B, 3C.
1A is a tuple and it's the first element in that list. 2B is a tuple again and it's the second element in this list, so forth.
Same goes for A, B, C also. They are also elements, right?
What do you mean when you say?
I mean the modifier. I mean the zip after applying the zip function.
Yeah.
So A, B, and C. In after applying the function, they are also elements, right?
What do you mean they are also elements? This is an element. This is an element. This is an element, and each is a tuple. Each of them is a tuple. And A is an element of the tuple.
Yes.
And B is an element of this tuple. It's like a list of lists. Oh, except here it's a list of tuples.
Can we give like more than one argument? More than two arguments?
I think so, yeah. You can check or quickly run it. You can check the documentation. You should be able to do more than two. So this is somewhat useful, it's handy. List and dictionary comprehension. For example, let's take an example code here, right? You see the square brackets here are angular brackets here because I'm at the shell. So X is a list. I'm setting X to a list 1, 2, 3, 4, and then I'm creating a new list, an empty list. So I'm calling it X squared, and then I'm doing a simple for loop for item in X. So each element in the X, I am appending to the new list X squared item star item. So for each element in this list, I'm squaring that and I'm putting that into the new list. Right. So now X squared, I end up with 1, 4, 9, and 16. Right. So from one list, I build the second list. All this you can convert into a one-liner using something called as a list comprehension. And then later we'll talk about dictionary comprehension. So you can do that second line right there. That will basically do it. Same, first line is saying X equal to 1, 2, 3, 4. I'm saying X squared is equal to, in square brackets, I star I for I in X. So syntactically this seems a little dense. And basically X squared is basically will be set to 1, 4, and 16. So with this one line, I'm replacing 3 lines of the previous code and the loop. So the way you read the syntax of this is, you don't start from here, you start from for I in X. So for each element in X, you're computing I star I and putting it into a new list. And that new list is basically your answer. Let me go back and write the previous slide one time quickly. So I have X equal to 1, 2, 3, 4, and then X squared is empty, and then for I in X, X squared is dot append I star I, right? And then I say print I or something like that, or print X squared, whatever it is. So, and then in the next slide, I have basically the same line, and it's instead of 1, 2, 3, instead of these 3 lines, I got X squared is equal to square brackets I star I for I in X. What's that? Yeah. These 3 lines are equal to that one line. So the way you read it is, for I in X, you compute I star I. So as you go through X, you will have I star I in every for every element, and then you take that and you put that in the new list. So when I is 1, I star I is 1. You put that as an element, first element in the new list. When I is 2, I star I is 4, and you put that as the second element of the new list. And when I is 3, I star I is 9, and you put that as the third element, and so forth. So you end up with 1, 4, 9, 16. And the fact that it's a square means it's a list that you're building, and inside that you got this loop and then something. This is a good one-liner way to create a new list from the original list. Right? You can do slightly beyond that too. Look at this line. I star I for I in X, and then you can also throw if I greater than 2. So I is X is equal to 1, 2, 3, 4, right? So you do this I star I business only if I is greater than 2. So for the first 2 elements, I is not greater than 2, so you don't do anything there. So you only do for 3 and 4, which means your new list is only 9 and 16, 2 elements. If I is not greater than 2, then you don't put anything in the new list. You do that, so which means for when I was 1 or when I was 2, you do nothing. And for the next 2, you put 9 and 16. Any questions on this? So, this is handy. I would suggest that you try to remember this. You can only put if statement, you can't put another else or something after that, or an elif or an else or anything. You're only allowed one thing. Sometimes it's handy for quickly building another list. And I have some examples later too. Or exercises later to have you use this. Just similar to list comprehension is a dictionary comprehension. So let's say I have x, same thing, x equal to 1, 2, 3, 4, a list. Now I'm trying to build a dictionary, a quick dictionary from this. So I'll say something like x squared equal to curly braces now instead of square brackets. Curly braces because we know we use that for dictionary. And here I have for I in x, just like before, there I just had I star I, right? Now I have I colon I star I, because in a dictionary, I need to give both the key and the value. Whereas in a list, in the previous slide, I only needed to give the list. So I comma I star I, the first is the key, the second is the value for every I in the list. So I end up with 1, 1, 2, 4, 3, 9, 4, 16. This is my new dictionary. Again, you can use an if statement after that at the end if you want to, just like you can, just like I showed in the previous slide. So again, this is a one-liner way to quickly create a dictionary from a list.
So if you have a tuple, for example, if you have in the list 1, 1, 2, 3,
In the X?
pairs,
Yeah.
can you do a similar statement?
Yeah. Let's say you have, let's say we have that one, right? When I erased, let's say 7, 5, 3, 14, 7, 21, something like that. A list of tuples. And your question is, can you still do something like this? So you can say something, you can. I mean, it's just it's still a list, right, at the top level. So you can say x squared is equal to I colon, well, now you have to be, for when you do for I in x later, right? X is now a tuple, right? You can do something, so you have to keep, you can't just say I star I. There is no I star I for it. You can't multiply two tuples, right? So you just have to bear in mind I is a tuple. So maybe, I don't know, you want to do I of 0 is the first element as the key, and I of 1 as the second element as the value perhaps. So can someone tell me what this will give you? 1 colon 3, that's the first pair, and then 7, 5, and so forth, right? 3, 14, 7, 21. You can do whatever, you can do I of 0. I of 0 is now a number. You can do 2 times I of 0, or I of 0 times I of 1, or whatever, something like that. Or I of 1 times 3, and then accordingly these keys and values will change. So going back to your question, you're not limited to a list of one element list. You can do it on a list of tuples. In fact, the input doesn't even have to be numbers, right? That was a list of numbers, right? You can have an X like this is hello, world, there, or some word, let's say like this. Hi, let's say something. You can build, let's say you can build a dictionary out of this. You can say something like for I in X, right? let's say anything that's interesting we can do.
Can we use the range
Can you use range where?
for the key?
For the key in the dictionary?
Yeah.
What do you want to say? Range of what?
Range of length.
Range of length of I, you mean?
X. X.
X is the large list, right? So length of X is the 4. So range of 4 is 0, 1, 2, 3. So for every key in your dictionary will be the same key.
Okay, so it's not correct.
I mean, you can, but are range objects,
Yeah.
another question is, can range objects be usable as a key? But let me not get too complicated. So what I can do is, for I in X, which means I is a string every time, right? I can do something like I colon length of I. Can someone tell me what this will give me as an answer for X squared?
1, 5, 1, 5, 2, 5,
Hello.
3, 5, and
Hello, column 5.
1, 5.
Then the next word.
Yes,
Hello colon 5. I is hello, right? First time.
Yeah.
Hello colon 5. That's my first key, comma.
The word.
Word colon 5. And so forth. There colon 5 and hi colon 2. So again, you can build. So it's not just for numbers. It's also for any list really. How you are building the new dictionary depends on what you put here. Okay. So these list and dictionary comprehension, they are handy. So I would suggest you try to memorize this and try to use it. Once you get a feel for it, then you'll find them useful. Keep moving on to something else. This is sometimes important to remember. Boolean values and expressions, right? 0 and empty values are false. Anything else is true. Any form of 0 is false, and any non-zero is true. For example, 0 is false, 1 is true, 2 is true, minus 1 is true, so forth. What do I mean when I say 0 is true or 0 is false? What I mean is, if you use that inside an if statement, if I were 0 and if you say if I, then that will be false. Anything that is non-zero, let's say I have a variable I equal to 0, j equal to an empty string, k equal to an empty list, L equal to an empty dictionary, right? And so forth. Now if I say if I, then do something, else do something. How will this code work? I was 0, right? If I just say if I, will this be true, or this code will get run? Block A will run or block B will run? B will run. Because when I is 0, if I 0 means okay. When I said 0 is false, that's what I mean. If I use it inside an if statement, this will result in false. And because this is false, then else will run. If I say if not I, and then that will be true, not if false is true. Same thing, instead of I, if I say j, if j is an empty string. And therefore, again, code B will run. Similarly, if I say if k, again, k is an empty list. So any of these are false if they are used inside an if statement.
But if you specifically mention I equal to 0,
Yeah, then that will be
block A, right?
that will be block A. So that's a good thing to explain. So instead of saying if I said if I is equal to 0, then block A, else block B. Now, I is 0, so this will be true. So block A will run. But if I just said if I, and because I is 0, this is false, so block B will run. So here, this will run, But here, this will. Okay?
But is it that somebody who does the coding on a daily basis in Python uses the left method? Because it is,
Yeah, people use both kinds, but sometimes for these, yeah, they use this one too. Now, let's say if I is 1, or let's put it, instead of k being an empty list, let's say k were at 2 elements in it, 3 and 7. Now, if I say if k, block A or block B will run?
block A.
Block A will run. If it's an empty list,
And
it
block
will be
B.
false, but this is not an empty list, so this will be true. So block A will run. Similarly, if there's a non-empty dictionary, there is some, let's say 1 or 2 pairs of key values, then if of that will be true. If it is an empty dictionary, if of that will be false. And the last line I have special Python value none is always false. Okay, so moving on, this is one little thing. You can let's say if you were checking for 2 conditions inside an if statement, if x is greater than 0 and x is less than 1. In Python, you can do something like this: if 0 less than x less than 10. So you can combine the 2 AND conditions, in this case with x being greater than 0 and less than 10, into one expression like that. That's equal. Some of these, even if you don't remember, it's no big deal. You'll be able to write the code. And or operators. This is most times and are used to when you want both conditions to be met, and you use or when you want either condition to be met, right? But and or actually do more than just that. For example, most people use and or inside an if statement. If both of them are true, then do something, or if either one of them is true, then do something, right? But and or actually do a little beyond that. For example, I don't have to use, first thing, I don't have to use and or inside an if statement. I can use them even outside. Look at this. If I have 2, which is a 1 element list, right, and another 2 element list, if I said 2 and 3, 4, I get this is the answer. This actually returns something. And it's not just true or false. It actually returned 3, 4. Or in another example, if I set an empty list and a number 5, this actually returns an empty list. So the way AND actually works is, and it's an operator, AND operator works is it returns either the first false object or the last object. So when I have something and something, it walks from left to right and finds out the first false object. In this case, this is not a false object. Remember, false list will be an empty list, and this is not an empty list. So this is not false, and so is this. This is also not false. So in other words, there is no false object. So it returns either the first false object or the last object. In this case, there is no false object, so it returns the last object. The last one is this one, 3, 4. The second example, it's again walking from left to right looking for the first false object. And in this case, this is a false object. An empty list is false. Remember from the previous slide. So it returns just that. It doesn't even check this one anymore. So it returns it. So this is what actually AND returns. But if you use it in, right?
So does Python also have the other and or, like instead of using A and D, you can use ampersand, or you can use like double pipes.
No,
like,
you use and or.
And does that also, those operators exist or they don't?
No.
Yeah,
Yeah.
okay.
This is more verbose English.
Okay.
Wait a minute. I think you can still use double ampersand. I'm getting confused now. You can check.
Or, and then for not, you can use a bank sign.
Yeah, I think you can still use these.
Is this sign? Or is it different?
Yeah.
Oh.
For example,
No, I think that if you adopt this problem,
For example, you can say something like 2 and 3. If 2 and 3, it's not allowing me.
Maybe
If 2 and 3, then I can, right? Print hello. So a double ampersand is not allowed. All is also not allowed.
So in this case, when we use it in if context, an AND operator will always end up being true.
Yeah. So the AND operator will always give you what you generally expect.
Unless both of them are 0 and 0. But
Yeah.
in this case also.
So before we go there, so AND operator, and we'll see OR in the next slide. This is what it actually does. Most people don't use it this way, but this is what it actually does. It actually returns something. But what most people do is they use it inside an if statement. And therefore, they are not really interested in what the return value of the AND operator is. They're only interested in whether it's true or false. Because if statement only worries about if it's true or false. For example, if you said if 2 and 3, 4, then block A, then else run block B, right? So 2 and 3, 4 actually returns 3, 4, but you don't care about what it returns. You just want to know if the return value is true or not. In this case, this will return 3 on 3, 4, and 3, 4 is true, right? It's not an empty list. Therefore, it will run block A. Similarly, if you do second one, if empty list and 5, then block A, then else block B. This will return an empty list. An empty list is false, and therefore it will run block B. So this is how most people use it inside an if statement. But what you can also do if you remember this is you don't have to. You can say something like A is equal to 2 and 3, 4, right? This is not an if statement. This is an assignment statement. And in this case, A will be 3, 4.
So 2 and 3, 4 return 3, 4?
Yeah.
3, 4?
Yeah.
Why is that?
That's what I've been saying for the last 5 minutes. Sorry to pick on you, but it actually returns something
Funny, huh?
more useful. It actually returns something more useful than just a true or false. You can use it if you really understand and remember it. But what most people do is they just use it whether it returns true or false in an if statement. If you use it in an if statement, you don't care what it actually returns as long as it's true or false. You just want to know if it's true or false.
I know it's not false, right?
Mm-hmm.
Returning 3, 4.
Yeah, that's what it actually does. It's again, most people don't do it that way, but you can if you want to. Similarly, is OR object or operator. Sorry. For example, if you have 2 or 3, 4, it actually returns 2. So the OR operator, how it works is it either returns the first true object or the last object.
So it's the same as in.
No, it's the opposite of that.
The opposite.
Oh, sorry.
Yeah, or let's go back. It returns the first false object or the last object. This one, it returns the first true object or the last object. So in this case, in the first example, it returns the first true object. In this case, it goes from left to right. So the first object it will check with this guy. And in this case, it is a true object because it is not an empty list. So it will return that. Done. It doesn't matter what is here because it found the first true object. In this case, empty list or 5. And notice also that the data types don't have to be the same type. Here I have two lists, but here I have a list and an integer. That's totally fine for and OR objects. So here, it goes from left to right. It keeps looking for the first true object, and the first object is an empty list, and that is not true. So we keep going. We go to 5, and that is true. It's an integer 5. It's not 0. So that is a true object. So it will return that. So this is what OR does. Again, once again, just like AND, most people use it inside an if statement. They don't really care about what it does. But you can, if you're smart, you can, and you remember how this works, you can actually use it in an assignment. So something like this, A equal to this and this, or B equal to something and or something, and then you return that. Evaluation stops as soon as the expression is found, as soon as a true expression is found for the OR operator, or as soon as a false expression is found for the AND operator. So once it finds what it wants, as it goes from left to right, it will stop. So that's about AND and OR operators. And the next one is, skip past and come back. So is and is not, right? This is not often used, especially in if you're writing, unless you're writing some big code using classes and objects and stuff. For example, you have x equal to a single element list. By the way, this is not an empty list. This is a single element list. So if you use this in an if statement, will this be true or false? It will be true, because there is an element in it. It's not an empty list. So x equal to that, and let's say y is equal to x comma 1. X is of course referring to that line right there. And if you ask the question x is y of 0, y of 0 is x, right? So x is y of 0 is true. They reference the same object. You may think, what is the difference between this and saying x double equal to y of 0? Now notice in this way what I'm doing. X equal to square bracket 0. Even though now x has been assigned to a different object now. Meaning, even though the value is the same as before, remember it was the same value as here and here, but it's a different object even though the value is the same. So now if you ask the question, x is y of 0, it will be false. Y of 0 is pointing to the original value of list 0. Whereas x is now pointing, even though the value is the same, it's pointing to a different object. So now x is y of 0 is false. But the values are the same for x and y of 0. So if you say x equal to y of 0, in this case I'm checking for value, it will be true. But the object is not the same object. So it will be false. So with that, we come to the end of the next block of things. You can try these exercises. I think I also sent the solution for this also last night in the Yahoo group. Maybe later on, a little bit later on, we will spend some time looking at some of these or anything anyone wants to look at. Any questions on what we covered so far? So it's only 10 o'clock now, so let me spend another 30 minutes or so talking about something else, and then we'll take a break. So this also we talked about, this also I sent the slides for last night. So the next lecture is about functions, right? So far as you were probably solving the assignments, you were writing functions, right? Def and then a function, and then some parameters in some cases, in parentheses like that. Sometimes no parameters, and then a body of code inside function. So now let's look at the next few slides we'll look at what all these functions are capable of. There's a lot of innovation even here. You can do a lot of things just at the function definition level. So without worrying too much about what is inside the function, that is all Python. Now you know about all the basic data types. So what goes inside the body is, you can train things around that. But let's look at the parameters and what you can do there, right? So this is how a basic function definition looks like. You already know that. Let's look at this function. So def fact, factorial of n, you pass in an argument and it's doing something inside, and in the end it's returning something. But now don't worry about what it's doing inside. Just focus on the overall structure of the function. And here I got a doc string. We briefly talked about this early on. This returns the fact that you can put any string you want in the very first line. It cannot be in third line or fourth or whatever. It has to be in the first line. And this is not a comment. This is a doc string. Notice that, remember comments start with a count character, and there is no count character here. This is not a comment. It is what we call as a doc string. You can, if you use triple quotes, you can write as many lines of code, as many lines of text as you want. It's free form, you can write whatever you want. And people usually write something about what that function does, what are the inputs, what are the outputs, like a documentation for that function. Inputs, outputs, what are the known bugs in it, known issues, or any special things you want to say about that function. Maybe even describe the logic of how that function works and so forth. This is optional, you don't have to have it. In fact, some of the functions that you may have written so far may not have had a doc string, and that's okay. Python still runs that code fine. But you're encouraged to put something so that if someone else is looking at that method, or maybe you yourself are looking at that method 3 months from now when you would have forgotten, you can just read that quick English sentence and understand what it is. And the best part about this is this. You can access this string programmatically from outside the function by saying that function name, fact in this case, dot, double underscore doc, double underscore. This will actually return that string. So I can show that. So for example, let's say I define a function def f, right? And then I put a, you don't have to have a triple quoted line, some text, this function f does blah, blah, whatever, right? You don't even have to use triple quoted, although the general convention is to use triple quote. You don't have to use triple quote. I'm going to use single quote just for kicks. And then this function does that, and then I'll say a equal to 1, return. I'm going to not return anything. So that's my okay, so I'll say if I say f, if I run that function, it just ran that function, nothing happened. But if I say f dot double underscore doc double underscore, I get that string. That's what I'm talking about. This function f does blah.
That should be enclosed in triple quotes, you know?
What's that?
I thought that the doc string should be enclosed in triple
No,
quotes.
it doesn't have to be. It just needs to be a string.
Oh, okay.
And in this case, I put double quotes, as you saw. It doesn't have to be triple quotes. People usually put triple quotes because it gives them the convenience of writing in multiple lines and pressing enter, going to the next line, pressing enter, going to the next line, and not have to escape the new line character with the backslash.
And they can have single quote and double quote within the string too.
Yeah, and you can put double quotes, single quotes, and you don't have to escape any special character or anything like that. But you don't have to use triple quotes.
Why do you assign value to each?
You don't have to. I mean, I just put the line there.
Oh, this is that.
Yeah, and I can define another function like that, without that, right? Yeah. And now
So
I
Python, you can call that function, and you can also use that when you're developing.
Right? In this function, I remove a equal to 1. In this function, I have nothing. And that's still a legal function. It's not doing anything, but it's legal. There's nothing wrong syntactically or programmatically wrong with it. Sorry, there's another question.
Yes. Python has a subset of these magic functions that start with underscore.
Variables, not double underscore.
Double underscore.
Double
Yeah.
underscore.
What is that?
So that's a system, they just pick that double underscore in the beginning and double underscore in the end. Whenever you see that, those are system defined variables. And doc is one such one here. There's a few other ones too.
So is it like the functions that come with Python, except it's a variable that comes with Python?
Yeah.
Got it.
Yes.
You said there's a way to look at all those variables from the shell prompt. What was that called?
Dir.
Yeah.
So, so I was able to programmatically print that from outside, right? But there's more things that Python can do. I'm just gonna tell, I'm not gonna be able to show. Is if you have like a bunch, if you have like you wrote a lot of code, let's say there are 5 files that you wrote, and each file has 20 functions in it, so total you have 100 functions. And if you're disciplined enough to write a docstring for all of them, what Python can do, there's a method, I forget, you can actually build a nice HTML compilation of the documentation for that entire project of 100 functions that you have. It will give you a nice HTML file, color-coded, all the inputs, all the outputs, and everything, all the doc strings, and you can click and go to the function and so forth. It basically builds a documentation for the project.
How do you invoke it?
I have to look up the command. You can read it up too. So what Python basically did to compile the documentation is it pulled out all the strings, doc strings that you have defined for each of your functions, and it put them in a nice to read format. So that is another way where. So in other words, as you're writing the code, it's able to pull out all the necessary pieces and build documentation. So that's one option. Again, it's optional, it's not required, but it's encouraged. So that's about doc strings. Now let's look at some of the parameters, like X and Y, right? These are what we call positional parameters. In other words, the first argument is X, second argument is Y, right? So you call it like this, power 3, 3. So in other words, X will get set to 3. Y will get set to the second 3, and then it did what it. For now, don't worry about what it's doing. It turns out it's doing 3 to the power of 3. The point is, these are positional parameters. If you swap the order, in this case, both the inputs are the same, but if you put 2 and a 3, or 3 and a 2 instead, the output will be different, right? Because the position is important. What goes to X is the first number. What goes to Y is the second. If you want it the other way, then too bad, right? It's okay for 2 elements like this, but if you have 7 inputs or 10 inputs to the function, let's say, 10 arguments, 10 parameters, then it's painful to require users to give the 10, all the 10 in the right order, and if you accidentally miss one or swap the order, then back, you get a different output, right? So there is ways to ease the pain there. And let's look at some of the next. Well, before we even talk about that, if you only give one argument to this function, which requires 2 arguments, boom, it's not going to do it for you. And it's telling you, this takes exactly 2 positional arguments and you only gave 1. Yes?
Is the word argument and parameter synonymous?
Yeah. I'm using it synonymous.
Is it really
No,
synonymous?
yeah, people use it that way.
What about attribute?
Attribute you use in the context of a class, usually. It's the member of a class.
Okay, so that's below our pay grade right now.
Yeah, but next week you
Or above our pay grade.
next week you'll be promoted and you'll get there when we talk about classes, attributes. So arguments and parameters are synonymous. So in this case, this function requires 2 arguments, and you only get 1, and so it fails. Okay? So in other words, it's hard and rigid on how you pass the inputs. There are certain things you can do to ease the pain there. For example, look at this function definition. So you have def fun, that's the name of the function. They say arg1, comma arg2. Normally we say arg1, comma arg2, comma arg3, right? Here you're saying arg1, comma arg2 equal to default 2, arg3 equal to default 3, and so forth. The way how it works is, let's say there are only 3 arguments, arg1, arg2, arg3. If you give all 3, when you call that function, if you give 1, 3, 7, whatever, arg1 will be 1, arg3 will be 3, or whatever you give, right? But if you only give 1 and skip the others, that is legal. What will happen is, because you skip giving the others, the default value that you provided, the definition of the function will be used. Let's look at an example.
If you don't use the default values, will it say it's supposed to take 3, but you only gave 1?
No, it won't fail, it will run.
Well, if you don't use that default values thing that you just had up there, then will it fail?
And your
Yeah,
question is
either
the
way.
default value is not defined.
I'm not sure I understand your question. Look at this example and tell me if you, please feel free to ask if your question is still not answered. Here, I have the same method, only I have 2 additional characters equal to 2. Everything else is the same. X, comma, y equal to 2 is the new thing from the previous slide. Now, I can run a power, so that's my function definition, and when I run it here, I can say power 3, comma 3. In other words, I'm passing 2 arguments. The first argument, x will be set to 3, y will be set to 3. And look at this. In this case, I'm only passing 1 argument. In the previous example, this one resulted in an error. It said the function requires 2 arguments, you only give 1. But now it doesn't do that. Instead, x is set to 3, y, since I did not supply any y, a value of 2 will be used for y. So in this case, it's 3 squared, which will be 9. I don't know if that's your question.
Totally answered it.
Okay, good, good. So this function, in other words, is a little bit more flexible to the user. Users can supply 2 arguments or supply 1. And when they supply 1, Python will use whatever you gave as the default value of the function definition.
So can I set a default value for x as well?
Yeah.
And then just and when invoking the function, can I just pass value for y and not x?
There's another way to do that in a minute. You'll see that. So this is somewhat easy on the, let's say, extending this to prior example where I was saying, let's say there are 10 arguments that this function requires, but let's say 8 of those 10 are defaulted to some value. Then at the minimum, user only needs to give the other 2. If I don't give the other 8, then Python will use whatever the default values for those 8 are, right? That's convenient. Or I can give 3 and then the remaining 7 will get defaulted. I can give 6 and the remaining 4 will get defaulted, and so forth. So I have more flexibility there in the number of arguments I need to supply, right? So that's pretty powerful. And the only thing syntactically is this additional 2 parameters equal to 2. That's all it takes.
It work if we say y is equal to default and define y somewhere in the middle of the code. So we write y is equal to default.
Yeah.
And define y somewhere in the middle of the code. Like r is equal to 1.
Yeah.
Put in the next line y is equal to 2.
Yeah.
That can be considered as
No,
default,
no. In that case, if I supply 3, comma 3, which means I want y to be 3, but if I have a y equal to 2 inside the code, my 3 is getting erased and replaced with 2, right? That's the problem.
It will not work or it
It'll work for a value of 2,
will?
even though I gave it 3.
3, okay.
Right? If I gave 3, I want you to run it as 3, not as 2.
But it's not an argument anymore, right?
Yeah, well, it's not a default argument anymore. In this case, you're talking about that.
Yeah.
So if I put a y equal to 2 inside the function, that is not same as putting y equal to 2 at the function argument.
So that becomes irrelevant, right?
If you
If
put it
you have
inside,
it, yeah.
if you put it inside, yes. Whatever you pass it from outside becomes irrelevant. So in summary, there is some flexibility here. You can now supply 2 arguments or 1, right? Whatever is defaulted, you don't have to supply if you want that value of 2 to be used. Let's keep going. There's another style you can pass in. Normally when you say you can call them like this, 2, 3 or 3, 2 or whatever, right? You can also do something like this for those x and y. You can say y equal to 4 or comma x equal to 2. This is what you were asking earlier, where the benefit here is, in these cases, the first has to be x, the second has to be y, right? Notice here I'm flipping the order. I'm supplying y first and then x. So if I say y equal to this and x equal to this, then I'm able to, I don't even have to remember the order I have to supply. I just have to remember the word, the name of the argument as defined in the function definition, and then I can switch them in any order I want. When it is 2 arguments like this, it's no big deal, it's easy to remember. But when there are 10 arguments like this, it's hard to remember the order of all those 10, right? What's the second, what is the 7th one, what's the 9th one, so forth. But if I'm able to supply the names also, then like this, then I don't have to remember the order. I can give them in any order. As long as I use the variable name correctly, argument name correctly, it will get used properly.
So in the last example, if I invoke the function like power of y is equal to 4, comma 3, and
if you say comma 3, that's a problem now, because it doesn't know what is 3.
Okay, go and substitute for the variable that is not, okay.
Yeah. That would be an error. So this is called keyword passing. Keywords are being x and y. So this is another flexibility that you have when you're running functions.
Question.
Yeah.
But you also need to know exactly the variable names.
Yes.
If you use something else, A and B, then it fails.
Yeah. Yeah. That's still required. The order is being flexible. You still have to give the name A, whatever the name.
Whatever
in the function definition, you define x and y, but when you call them here, you say A and B.
Yeah. You will fail.
It's not going to be Python. No, even you wouldn't know, right? How can you know which one is x and which one is y if you gave A and B instead? Right. So, and this keyword passing ability can be combined with the default arguments ability also. So those are 2 things. And then let's look at another example, another flexibility. Ability to pass variable number or infinite number of arguments. Let's look at an example to show what I mean. Let's look at this example. Def maximum star number. The only thing that's different is star here. And then, so that's the input that people give. And then it's doing something inside. For now, don't worry too much. For now, don't worry about what is going on inside. Now let's jump to how we are running it. Remember, this portion of the class is about functions. So we don't focus on what is inside the code. Instead, we focus on the first line, the inputs, arguments. Now, look at how I'm calling it. I'm calling the function maximum 3, 2, 8. And then this function, it turns out, it returns the maximum of the numbers. Notice that I'm not passing a list of 3 elements. I am passing 3 different elements, right? If I'm passing a list, you would have seen a square bracket. I want to make that clear so that the number of arguments, the number of parameters going to this function are 3, not 1. But look there, I only have 1 argument. So that's the power of this variable passing, variable number of arguments. And look at the next example. I'm passing 5 arguments. Again, this is not a list of numbers, it's 5 different numbers. There's no square bracket, right? If you got a list, you would have seen a square bracket. And so, what I'm saying is, the same function I'm calling with 3 elements, or 5 elements, or you can run this with 7 elements, or 24 elements, whatever you want. In other words, I'm able to call this function with variable number of arguments, right? That's possible in Python. all it took was this one little thing called star. So when you put a star, some variable, what Python will do is it will take all the inputs that you give, convert that into a list of elements, and then pass it in. So when you get 3 to 8 with 3 different numbers, what Python did when it saw the star there is it created a list of 3 to 8 in square brackets. So it's a one element now, right? So it converted those 3 to 8 into a list of one element is 3 to 8, and it passed this list into the variable numbers and ran this function. So if you write your code, assuming what you're going to get inside is a list, not a number or anything, then the code will run correctly. So you put star numbers, which means whatever comes to you inside is a list now. That is how you're able to use the len method, because we know len method can be used on lists, right? And then you can access the individual elements like this, numbers of 0, or you can slice the elements like this, and so forth. So in other words, I'm using, the whole code is written, internally is written assuming what comes in is a list. And yet, when people call that function, they don't have to pass in a list, they pass in any number of arguments they want. And that's the flexibility. Python will convert whatever the number that they give into a list. They don't have to do that. So in other words, it's called variable number of passes, variable number of arguments. All it took was a star, syntactically. And of course, you write your code assuming it's a list, not as a different arguments. Okay. So similarly, next one, variable number of arguments. You can also pass a key. You can combine that with a keyword passed argument as well by using a double star. So in other words, instead of now look at the example. So x comma y comma star star other. 2 stars now instead of 1. So when it is 2 stars, users have to supply key and value. In other words, you convert all this into a dictionary. Look at this. So look at these 2 elements for now, foo and bar, right? So when it gives star star other, you run that code by supplying key and value, and foo is 13, bar is 7. Notice that nowhere in here or anywhere are foo and bar defined. I can create them when I run this function, additional keys. And what Python will do now is just like it converted whatever you gave as a list in the previous slide, here it will convert these two into a dictionary, key and a value, and pass it in. Again, don't worry too much about what the code is doing, except that other is now a dictionary. So you can do something like other of keys, right? Other of k, and so forth. So the way this code will run, x will get set to 2, y will get set to that string 1, and everything else, if they are in key equal to value format, will get absorbed into other as a dictionary.
So it has to be other, or we just put star.
You have to give a name after star. Everything or other, some name. So this is all some flexible things you can do when you're calling functions. So when you're writing your function, you put star star and some variable name, and inside the function you assume that this is a dictionary, and you write your code as if that were a dictionary. That's why you're able to use other keys and so forth. The benefit here is people can create new keys, foo, bar, whatever you want, and then it will do what it will do using those. So keys in other, the output is printing the output, that one there, keys in other, the total values in other is 13 plus 7, computed to be 20. So you did something useful with that.
So, well, what's 13 and 7? Foo equal to 13 and bar equal to 7. So what does that
So that will go, both of those will go into other.
Is that the value to the key or?
So foo is the key, 13 is the value, that's one pair. And similarly, bar is a key and 7 is a value, and that's the second pair. So in other words, other is basically a dictionary. It gets set to foo, colon 13, comma, bar, colon 7. So that's what it is.
If you just gave a star other, will it not compile?
That's right. If you give star, only one star, not two, then that means you have to supply just a list of elements, not key equal to value kind of style. For this style, you have to have in the function definition double star. In the previous example, going back, where you only have one star, then users can only supply 3 to 8 like that. They can't say foo equal to 8, bar equal to 2, then this will also fail. So there is still some restriction, but it's still more flexible than without it. It's also possible to combine all the 4 things we talked about. Where one is defaulting the arguments, the other one is positional parameters, the ability to change the order. Third one is convert the inputs variable number into a list, and the fourth one was convert the variable number of the arguments into a dictionary. You can combine all that. Sometimes, depending on how you use it, can actually be confusing as well. But if you use it nicely, it will be convenient. Let's look at local, non-local, and global variables. Right. In this case, R and N are local variables. Right. I'm creating them here. N is of course I'm passing past N, but it's still a local variable inside. Any changes you make to them inside the function will not have an effect outside. Right. We've been using local variables whenever you created any variable inside a function, it was a local variable. Let's look at an example here. Notice that I'm running with the shell prompt here. So I define a function, def1, global A equal to 1, B equal to 2. And outside the function, obviously I didn't run this function yet, I only created it, I only defined it. I'm running it actually further down there. But let's walk through. I set A to be a string, B to be another string, and now I ran the fun method, which was that one. Now if I query, after executing the fun method, if I query A, I get the number 1 instead of that string. And that's because inside that function, I modified the global variable. I accessed to the global variable A and I modified it. So even when I query that value outside that function, I still get the modified value, the number 1. If I query the value B, I get the outside value, not the inside value. Can someone say why? That's right. So I only called global A, I didn't call global B. So inside, when that fun function ran, a new variable with the same name was created. So at that point, I had a local variable B and a global variable B. The local variable B was set to 2, but the global variable B was not modified at all. So that is why after running that function, when I query the global variable, I still get the old value, or I still get the global value. Any questions on that?
Call fun and then B, will you get 2?
If I say what?
Fun, if you invoke function first and then say B, is that different from saying?
That's what I did, right? I invoked the function and then I said B.
Even though you did A first.
I mean, this is not going to change this one. It's only printing it. Yeah, you can say if you had said global A comma B, and then A would have been 1 and like this, B would have been 2, the number 2. So let me write that thing in one line, in a slightly different way. So A equal to 1, B equals 2, right? And then def F, or I can say here print A comma B. You know what it will print? It will print these two, right? And then now I say def here, and then global A comma B, and then I say A equal to the number 1, B equal to. Instead of string and number for talking purposes harder, I will just use different numbers, the same thing. So instead of, so I'll say A equal to 3, B equal to 7, and inside function A equal to B, A equal to 1, B equal to 2, and I'll say print A comma B, right? And now outside the function, I call that function F. Remember, I'm only defining it here. I'm not actually running. This is when it actually runs. And then I say print A comma B. What will this print? 3 and 5. What will this print?
1 and 2.
1 and 2. And what about this? 1 and 2. Because I modify the global variables here, and after modification, if I query it, I'll get 1 and 2.
So before the function global values 3, and after you call after you put global inside the function, you change that global value.
That's right. Now let me ask a question. If I did not have this line, if I had erased that line, everything else is the same. Now I run. Here obviously I'll get 3, 5, right? And here I'll get what? 1, 2. And what I'll get here? 3, 5. Because when I erase this line, I'm no longer accessing global variables. I'm creating a new set of local variables. Right? Now, let me ask another question. If I had, let's say, a code like this, if I just had said here print A comma B, notice I don't have global variable, global A comma B. If I had said print A comma B right here, what will this print?
3, 5.
It will print 3, 5. So in other words, even though the global A comma B, that statement, is only really necessary if I am modifying the global variables. If I am not modifying the global variables, in this case, at this line I'm not modifying it. I'm kind of modifying label. Here, in this case I'm not modifying it, so I can still access global variables without actually declaring global A. So here it will print, and this is probably the key statement, so you may want to, so this will print, one more time, this will print 3, 5. What will this print?
1, 2.
This will print 1, 2. Right? Remember, since I did not say global A, B, if I'm creating A or B, a new variable, local variable will be created. And when I say A, B here, those will be printed. And when I say here print A, B, what will print? 3, 5. Because the local variables that were created are gone when I come out of that function. So the global values are still untouched, 3 and 5. That's the difference. So in other words, I'm able to access the global variables inside the function even without saying global A comma B. But if I want to modify a global variable, I have to say global A. That is why in the earlier example, when I had global A and I changed these two, and the global variables got changed. But if I don't say global A, then local variables will be created if I modify it.
Question.
Yeah.
Is that a best practice to global the variable?
So the best practice, which is not same as what is required, best practice is if you are ever using a global variable inside a function, always declare it, whether or not you're modifying it. That's the best practice. Also, global variables, keep them uppercase, fully uppercase, so you know it's a global variable. It's a general good to do. But legally though, if you are not modifying global variable, you don't have to supply, you don't have to use the word global variable, although it is recommended, best practice. So this could be some tricky interview questions or whatever. Or, so this is fine. You can do this, and it will actually print 3,5, even though you don't say global A, global B, because I'm not modifying them. But the moment I modify, a new set of local variables will be created. Because I did not say, because for modification purposes, I have to say global A if I want to modify global A. If I don't say that, then a local variable will be created.
So where's the part where you're declaring it? You said always declare it.
Yeah, so if you are using global variables internally inside a function, always make it a habit to declare them like that.
Okay, and where's the uppercase you said?
Well, here I'm using lowercase. I would use A.
Oh, just make it capital.
Uppercase. Then you would use A and B.
Okay, and the declare is where you have that with the line, the global AB?
Yeah.
That's what declares it. What's the declare? What is it?
I'm
What is
saying
it declared?
A and B are global variables.
It's just declaring that it's there.
Yeah.
You're not assigning a value. Just say it's there.
Just say it's there.
Okay.
Any questions on that?
So if you have a variable outside of the function, it's also a global variable, right? So you don't really have to specifically say
Yeah.
global.
Yeah. If you open a file and you say A equal to 1, that's like a global variable already.
Yeah.
If you have any other functions here, f func 1, func 2, func 3, for those, that's the global variable.
It's outside of the scope of the function.
Yeah.
So it's global.
Yeah.
What is it that makes it global? Because it's declared outside of the function?
That's right.
And if it was declared inside the function, then what? It's local?
It's global.
Local to that function. Okay.
Here we are calling function in the
Actually, kind of. Which part can you describe one more time, please?
the last one, we are calling the function, right? Here we
Yeah.
are calling the f function,
Yeah.
and we are printing a comma b.
Yeah.
So I was thinking that a comma b should be one because we are calling method.
So the code is written like this, right?
Yeah.
So let's come from the top. What will it print here? 3,5. That's easy, right?
Yeah.
Now I'm defining the function here and I'm running it here,
Yeah.
right? When I'm running it, these 4 lines will get run, right? And however, I don't have a global A or B here inside a declaration, which means if I'm modifying A and B, local values will get created, A and B. A will get set to 1, B will get set to 2. Therefore, this will print what? 1, 2. But the moment I come out of that function, these local variables are destroyed. They're gone. Because those are local to that function, they get created when I run that function and they get destroyed once I leave that function. So these two are no more. So A and B are still 3 and 5. So if I print A and B here, it will print 3 and 5. On the other hand, the opposite is if I do have a statement here called global A, right? Now, global A comma B, let's say. A and B in the subsequent lines will refer to the global values of A and B. So in other words, when I'm modifying them here, 3 will get replaced with 1 and 5 will get replaced with 2 because I have this line now. So this one will still print 1 and 2 like before, but this will also, even though when I come out of that function, because the A and B are now global values, they are modified, this will still print 1 and this will now print 1 and 2. Because this function accessed the global values of A and B and modified them. So even though the function execution is completed, the global values are still present. And those will now be A and B. So in other words, they were 3 and 5 before calling that function, and they got changed after calling that function, because that function modified the global values.
So the way you have it there, the first one it's 3 and 5. Inside it's 1 and 2. and then outside it stays 1 and 2?
That's right.
It doesn't go back to what it was before the 3, 5?
Yeah.
Why
Because-
doesn't it go back?
Because this function modified the global
You
value.
modify it, and then it retains that value when it goes out.
Yeah.
Mhm.
Global values, any function, once it modifies them, every function will see, or even outside the function, you will see that change. So this function modified it, so even after that function execution is completed, you will see that changed here. So that's the value of a global variable. Every function can modify it, or every function can read it also.
In Python, do we have statics? Value?
We don't have static. I think it's been a while since I used it in other languages. Static means what? After you call that function, and when you call it again later, that local value is retained.
Retained.
Yes. There is an equivalent of that we'll talk about in a few more slides later. But we don't have static, but there is something similar.
So question.
Yeah.
So it seems to me that it might be better to return the value instead of modifying the global variable.
Yeah, I mean, yeah. You're saying don't use or avoid using global value, instead pass a parameter and get an input or an output.
Right.
That in general should be the way we should write the code. But sometimes having a small number of them is very handy.
Okay.
So you don't have to pass in every little thing to the function, and sometimes it's handy. But if you overuse it though, when you should be actually passing, then code can get very confusing, and therefore it's likely to have more bugs. So a small amount of global number is actually good. So some constant values which should be the same throughout the program, and it's even better if you make them read-only, meaning no function actually modifies it. Every function only reads it, because those are constant. You don't expect people to change.
So you're saying best practice is use return of value, but having occasional global values as a shortcut is
It's
acceptable.
handy.
Handy.
It's handy.
And what's the other one, static? You said static we do not have in Python?
That's right. So at this point, I think let's take a break for 10 minutes. We'll come back and finish this. Okay, I'll be here if you have any questions.
Can you put that?
Value through the key. And then in the second loop, just do the same thing, whether view of key is equal to var is equal to right there. We can talk about it later.
You say at a higher level you want to avoid the inner for loop.
I want to avoid the outer for loop. So you can just iterate through all the keys and values and for key dot key.
Well, we can talk about it.
Okay.
Maybe if you have something that is working. Are you saying you have something that's working, or
No, but I can.
okay? We can talk about it, and I can explain. I do think you may need more than one. So let's continue. So we talked about global variables, right? Any questions on the global variables? So in summary, one more time, this can be confusing. It's a best practice to always declare inside a function any global variable that you are using, just say global, whatever. Right? And another practice is to use uppercase for the variable names for global variables. That way, whenever you modify, once you declare it, whenever you modify inside, it will be reflected outside.
It seems almost counterintuitive to say declare the global variable inside the function. Wouldn't you want to me, common sense says declare the global variable outside the function because it's global to everything. So why declare it inside the function?
So you define the global variable outside the function.
Define it outside the function.
Yeah. But inside the function, you declare it so you're having Python and use it in this function.
Okay, so define it outside the function means it exists.
Yes.
And then the other one is declare it into a value.
No, declare it just tells Python that I'm using it inside the function. Let's say I got a function a equal to or a global variable, and then I have a function here def and then global a, right? And then then here I say a equal to 2. And then I call that function here and I say print a outside. So here I'm defining a global variable here. I'm declaring it here and I'm modifying it here.
Okay, so I was thinking it was the same. So defining it outside just means it exists.
You're creating it.
You create it. And then declare it inside means what?
Means for the rest of that function, wherever you see uppercase A, think of the outer one is what you're saying.
So all it does is just remind you that it's
Remind Python. I'm reminding Python. Not even reminding, I'm telling you for the first time, which is not really reminding.
okay, reminding me, but telling Python for
Yeah.
the first time.
Yes.
That it is.
So that whatever I do with A inside the function is referring to this A.
referring to the other. Okay. But it still doesn't assign a value. The value is whatever the current value is. How does it get the value? How is it going to get a value to use?
So if I declare it like this, if I say print A right here, it will print 1.
Oh, just from whatever the.
Because the moment Python will see this line, it will allow this function to access this variable, and whatever I do with it, I will see. If I say print A, I will see 1. If I say it to 2, then I'm changing this value to 2.
Okay. But if you don't, this way you have the uppercase, lowercase, so you differentiate. But the way you had in the examples before the break, where you didn't use uppercase, you just used lowercase a for both, then the value would change.
No. Using an uppercase is a practice, recommended practice. You don't have to use uppercase.
Yeah. What I'm
So
saying
whether
is-
you use uppercase or lowercase, it's not going to change.
It's not going to change.
Case itself is not going to matter as long as you use the same variable name.
Oh, so so now I'm wrong again. So the uppercase A is the same as the lowercase a for variable, for value. Is that what you mean? Or is the uppercase A
No,
variable different than the lowercase a?
No, if I have another, if I say another print A, comma A or something here, lower than that, those are 2 different variables.
Those are 2 different variables.
Python is case sensitive.
It is case sensitive.
So if you have another, uppercase A is different from lowercase a. But what I am saying is, for global variables, use uppercase.
Just use uppercase.
The reason I'm saying that is it will stand not for runtime purposes. The code will still run whether you use uppercase or lowercase, but it will look better for global variables if you use uppercase. They stand out in your code.
And avoid humans from getting confused.
Yes.
Okay. All right. So it's different. The thing I wasn't sure. So it's defined as different than outside than declared. Those are 2 different things.
Yeah. Okay. So this is definitely confusing because there are many options here. Now the other thing also I was telling you, if I want to confuse you one more time, is
Sure, we would love to be confused. Just interesting.
is what happens if you don't put this line, and then what happens if you don't put this line but try to access outside variable or try to modify it. So that's where things change. If you I don't want to repeat and maybe confuse you. It seems like you got something really there now. Okay, so that's about global variables. Non-local variables, they're not often used, so I'm not going to talk about them. But if you're interested, you can look at the dictionary, look at the manuals. There's something else called non-local. There's a local, there's a global, and there's something in the middle called non-local. It happens, it's useful when you have a function inside another function. Again, they will get complicated, so I would not rather go into it. You can have a function defined, and inside that function, another function defined. That's when non-local comes into picture. Let me move on. Functions are very powerful. Functions are also objects. Anything in Python is really an object. So are functions. What that means is functions can be treated just like variables. When when you said a equal to 5, you put the number 5 in a, right? The variable. You can, instead of 5, you can put a function. So that's what I'm saying. We'll see that in the next slide. But for now, I have two functions defined, right? Here, there's one and another. Each of these functions is accepting an argument. This is in terms of, this is converting Fahrenheit temperature into Kelvin, and this is converting Celsius temperature to Kelvin using some arithmetic, right? So at the end of the day, it's function F to Kelvin or C to Kelvin, each in degrees F and some arithmetic. So two functions are defined. And look what I'm doing in the very first line there. So so we can refer back to it. Maybe I'll write those functions here. Right. So let's say def F to Kelvin, right? And then it's taking something degree and then it's doing something here. And then there's another function def C to Kelvin. And then it's taking another example and put here and doing something. Now let's go to the next slide. So in other words, F to Kelvin is my one function and C to Kelvin is another. Look at the very first line. I'm creating a variable called abs temperature. And look what I'm assigning it to. Normally, I can say abs temperature is equal to 5 or something, or 7 or whatever, or a string or a dictionary. I can say equal to 5 or equal to string hello, or not. That's what we are normally used to, right? Or a list of 5 elements, right? Or a dictionary and so forth. But look what I did there on the very first line. I assigned it to a function. That's possible to do in Python. Functions are objects just like any other data types are. So you can assign them to a variable. So I created a variable abs temperature and assigned it to a function. So in other words, abs temperature is now just another name for that function. So instead of calling F to Kelvin 32, I can now call it abs temperature 32. So essentially, I've created another name for that function.
What's the practical difference in doing that? What's the practical purpose in doing that?
Why would we want to do that? You can basically condense it further and further, as you will see in the next slide and then next. But just bear with me there. So in other words, I ran that function without actually calling its function name, but by calling another name, right? Temperature. Notice that when I put parentheses, I'm running that function. I'm running that function by supplying an argument. Here, when I said F to Kelvin, I'm not running that function. I'm referring to the function object. I'm only running it when I put a parenthesis and supply an argument. Or if the function does not take any arguments, just put a parenthesis with nothing in it. And then it actually ran that function and gave me the output, whatever that function returned, right? And that's what 273 point something. And in the next line, I'm taking the variable again and assigning it to my second function. Again, I'm assigning it to the function object. I'm not actually running it. You have to put parentheses and some parameter inside in order to run it. So now in this line, now I'm calling abs temperature 0. Now C to Kelvin function will run because that's the most recent assignment, and an argument 0 will be passed. So in other words, I'm using a function variable. I'm using a variable abs temperature, and at different points in time in the code, I'm assigning it to a different function, and I'm running that function using that variable. One time here, and another time here. So in other words, at a high level, I'm assigning a function to a variable, right? And look what I have. So that's possible to do in Python. And building on that, look at this. This is a dictionary. You can see when you see curly braces with a key colon value, you know it's a dictionary, right? And it has two pairs. First pair is a string. The key is a string. The value is a function. F to Kelvin. And the second key value pair, again, the key is a string, C to K. The value again is a function. So for this dictionary, keys are strings, values are functions. And look what I do in the next two lines. This is condensing all the stuff into smaller and compact code. So P of F to K. Normally, when you say P of F to K, and F to K is the key, you get the value of that key, right? So T of F to K would refer to this function F to Kelvin. And then I'm putting parentheses and putting 32. In other words, I'm running that function with 32 as the input. And I get that output, same as before. That's how I can run the first function. And when I say T of C to K, which means I'm trying to get this value, and then I'm in parentheses I put a 0, that means I run that function.
So it's kind of like shorthand for coding, the way secretaries used to have the shorthand symbols, and instead of writing out whole sentences, they had shorthand symbols. It's like shorthand for coding.
You can say that at the high level, but I'm able to compact multiple functions and into a dictionary, and I'm able to run any of those functions just by calling the keys of that dictionary and supplying an SSD argument to run that function. Yeah, at a high level, yeah. You can do that.
And it's called what? Assigning a function to a variable.
Yeah. Because that's what I did here, and that's kind of what I did here too. I'm assigning the function to a value of a dictionary. Because functions are objects, you can do that.
So question, so the function name is the object, so that object you can assign it to any variable you want, and then use that variable to call that object.
That's right. To run that function.
To run that function.
Yeah.
Nice.
Okay, so let's keep going. We're gonna have.
Do other languages have that, like Perl and Ruby, or I haven't heard of that before?
I'm not very good in the other two languages as far as I know, though. But again, I'm not expert in those two languages. So this is powerful. So you're asking why would one want to do that? You can do something like this. See, now I squeeze two functions into a dictionary, and I can call any of those functions just by accessing a key of a particular key in the dictionary and passing something.
That I get.
Yeah.
Renaming it though, why would you want to rename it?
No, this is the same thing as that. Here I'm renaming it to a variable, here I'm renaming it to a value of a key in a dictionary. I mean, I'm setting a value of a key to be that function.
Right, so that makes sense because you can compute it within the dictionary.
Yeah, I mean, but the idea is the same thing. You explain this so it's a little bit easier to understand, and then you build on this. If I show this without going through that, it would be harder to understand.
Okay, I get all that. Yeah. My question is there like in the real world, would you ever be the first one?
I mean, you can conceivably have, let's say, multiple functions like this. Let's say there are 5 functions like this, which are doing something like maybe Fahrenheit to Kelvin, centigrade to Kelvin, Kelvin to centigrade, blah blah blah, so forth. And then you can presumably iterate through a loop of some kind, and each time you can run a different function using the same variable. Let's say I have 3 let's just calling such a big name F1, F2, F3, F4, F5, right? I can create a list of each of those 5 functions, right? Because these are objects, I can use them like this. And then I can iterate this for I in F. I can run that function I of 0 or by passing something. So in this case, I is getting renamed to F1 the first iteration, set to F2 the second, and so forth.
That makes sense, thank you.
It's almost like a collection of functions, right?
The way I have used it here, yes, a collection of functions.
So you put those functions in the dictionary or?
Here, this is just one use case. There are many other ways you can use it. Let's say I have functions F1, F2, F3, F4, F5. I put that in a list, and then I'm iterating, looping over that list.
So you assign F1 equal to
No, I'm saying the function name itself is F1 instead of C2 Kelvin or C2. I didn't want to write such a long name, so I just wrote F1. You can put all those functions into a list and loop over that list, and right? It's pretty powerful that way.
Yeah, you have multiple lists of tasks you need to do different things in there. And
Yep. Okay, so moving on to something called lambda expressions. Analog of this in other languages is something called inline functions, quick one-line functions you can define sometimes. Here, for some reason that I don't know, they're calling it lambda. It's anonymous functions. They don't have a name. So the syntax looks like this. Lambda, you typically use that function right where you define it. And normally you define that function here and you call it somewhere else, right? Here, these are one-line little functions that you just define it there and use it.
So it's like doing it in an interpreter, like when you put something in an
Yeah.
interpreter, right?
Yeah.
And it's not
Actually,
recorded.
it's not, because even in the interpreter, you have to define the function and call it later, right? Let's look at an example. The same temperature dictionary that I had in a couple slides ago, I have the same thing here. I'm calling it T2, and the key is the same thing, FT Kelvin, and the value, if you recall there, I had the two functions defined ahead of time, and I put the name of that functions here, right? Same thing for C2K as the key and the value. Now, instead of defining it first in another place and calling that name here in this dictionary, I'm just defining the value of this key to be the same dictionary, to be the actual function right there. In other words, I define the function also right here. And what is that function? It's an inline function. Lambda, and then the syntax is there is no function name. Normally you have a def and then a function name, right? Here you don't have a def to begin with, instead you have a lambda, and there is no function name. The first thing you give is degree Fahrenheit. That's the argument you supply to that function, and then a colon, and then an expression. You're only allowed to have one line in there. You cannot have more than one line. And that expression is also the return value of that function. So in other words, this Python function accepts one argument and it returns that expression.
What do you mean by one line?
You can't have A equal to B first line, A equal to 3 first line, and second line C equal to 7, third line, you have to fit everything in one line. You're allowed to have one line of code. So after that colon there, that expression is what is that one line, and that expression is also the return value of that function.
Kind of similar to the list comprehension.
It is somewhat similar to that, where there too you're allowed one line, right?
Can you reuse that expression anywhere? Is that expression remembered? If it doesn't have a name?
Well, in this case, even though this function doesn't have a name, you can get to it using this key. This is a dictionary, right? So if you get the value of this key, it's basically that function. So that's how you can get to it even though it doesn't have a name.
Can lambdas be only used in dictionaries or other places?
So you can use it outside too. You can, in this example I have it inside. So T2 again, that's the key, and that's the value of that key, a function, a lambda function. And similarly, a second key, C2K, and that's the value of that key.
It probably runs faster than this way.
Yeah, this probably runs faster, but it's a one line. It's also somewhat limited because you can only have one line in that function.
So how many arguments you can put in there?
You can give arguments. You can have any number of arguments.
Okay.
In this example, I have only one argument, degree F or degree C later, right? But you can have more than one.
Where would using a lambda be more like better than defining function using that?
It's basically for quick one-time usage instead of creating another function and then calling that here, which is a couple lines extra code. You can just do it right here. So for small things instead of creating another function and then writing it here, just be done right here. That's all. Performance may be slightly better because whenever you create another function, Python, you have to put that separately in the memory and call that. So the overhead of calling a function isn't there here because it's inline. That's basically it. You can't make mistake one way or another if you're writing small code. But also, let me ask you this: if you were to write one line of code, you're only allowed to. Notice that this is one line, right? It's kind of long, but one line. If you're allowed to have one line of code and you have to define two functions and a dictionary and two keys in it, how would you do that? You cannot do that in one line otherwise. Okay. Is it a worthy problem to solve? That's a different story. Sorry, go ahead.
Use the expression the way you showed earlier. Assigning the expression.
Like
Not
this?
assigning the function.
Yeah, but this is not one line. You have to still define these two functions ahead and then create this dictionary. Right?
That's how you have to do all that.
The F2 Kelvin has to be still defined like this. Right? So once I define it, then I'm using it here. Now I'm condensing that slide and this slide line into one line here. You cannot do it in one line if you do not use lambda expressions.
Is there ever a situation where you are limited to one line?
Yeah, I mean,
Like in real life? Do you ever have a set amount of code that you can?
if you're writing code on a smaller processors, or like a phone, or a simple, or a smaller memory footprint, like an embedded device where you are limited in memory. You don't, like on computers, we have gigabytes of memory. You throw a few extra variables, no big deal, it'll just run. But when your memory on the computer available, it's not a real computer at that point. It's probably an embedded, like a projector, or I don't know, a digital clock or something like that. You're writing some code there, then you don't want to use a lot of memory because memory is very precious. You don't want to put a lot of memory because that will increase the cost of your device, whatever you're making. Then you have to squeeze every byte there, or CPU speed may not be very high. In other words, if you are liberal in your code programming, then you spend performance of the device may not be as good. So when those issues come, you have to worry about all these things.
Like a set-top box.
Yeah, the set-top box, Comcast box. Each of these, they don't have a lot of processing power like gigahertz of CPU, like Intel CPU, or gigabytes of memory. You only have a few hundred megabytes of memory and perhaps a few hundred megahertz of processing speed. So in those situations, some of those matter.
Downside is that it's not reusable.
It's not what?
Reusable.
Yes. Yes. So the lambda function, well, in this case, it kind of is because you can always get to it using the key. But yes, if your desire is to reuse that function in many places, then you will want to create a separate function definition, def, give it a function name and use that, and then repeatedly use that. But if you don't intend to repeatedly call that function, you just want to fire one place, one time, then just lambda is a good choice. Yeah.
Yeah, on that scenario, can you just use the expression without lambda, dg, just put the formula and produce the value?
No, but notice that I'm passing an argument.
Okay.
So I have the flexibility of supplying 32 or 33 or whatever number, right?
Okay.
It's a good question. Why?
What happens if you don't put the lambda?
That's exactly what he was asking. All you're doing is one expression. Why don't you just put that expression as a value?
Right.
But it's not just an expression. I have the ability to pass in a number. Right? Degree F. Notice that I'm passing 32. I can rerun that function, same thing again, with 35 or 37, some other input, right? If I give an expression like this, how can I pass in a number?
Yeah.
You can't, right? That is why a lambda expression, lambda function is useful. You can still pass in that.
Yes.
And by putting the word lambda, that's what makes it this lambda expression? And that,
Yes.
just that one word lambda?
Yeah. It's a function, lambda function.
Okay, and what's the reason for having the one line restriction? Is that just by definition what the lambda is?
Yeah. That's what it's supposed to address, a one line. Okay? Get it or not too, don't worry too much about it because if you don't remember lambda functions, you can still write, and I imagine for the next 5 years, or whatever code you will write, if you were to get really, even if you didn't remember lambda, you'll be fine. If you're getting really, really advanced, and at which point you don't need my class, you can learn this on your own.
And the other thing you said, what was the inline means? Inline is the way that's equivalent to this in other language?
Yeah.
Okay, so like Perl, Python, I mean.
I know it's called in C language,
C.
inline. I don't know what it is called in Perl.
Okay.
I think all this is called functional programming, and it has different ways of doing it.
Okay, yeah.
What's that?
It's called functional programming.
Functional.
Yes.
Now let's go to something else called generator. This is the equivalent of static that you were asking earlier. Let's jump to an example. Let's look at this example. Def4, and walk through the code to see what it's doing. X is 0, right? Okay. While x is less than 4, I'm running a little while loop of 3 lines in it. First line, I'm printing the generator x, the value of x. The next line, I said yield x. That's something new, right? And then x equal to x plus 1, that's easy. So in a while loop, everything seems similar to this regular while loop. The only line is yield equal to x. And that's basically is how you build generator functions. The higher level idea before I explain the code and how it works is if I were to give a list L equal to some numbers, right? I'm iterating over a loop, over a list, or a dictionary of something, then I'm iterating over that dictionary. And in other words, how it iterates, what it iterates is the data that I have control over, but how it iterates is determined by Python. In other words, it goes to this one first, then it goes to this one, then it goes to this one, then it goes to this one. What if I want it to go to this one first, then come here, then come here, then go there, then come the order? If I want to mess up some of the how it iterates, then I don't have control over in a for loop or a regular while loop or whatever, right? It's the order of iteration is determined by Python, and this is an attempt at giving an option for you to decide how it should iterate. In other words, building your own iterator. That's where generator functions come in, right? So with that in mind, let's look at this example. So, I have another slide. Actually, let me write this one on the wall whiteboard, and then we'll go to the next slide. So I have def for x equal to 4, while x less than 4, that print in generator x equal to x, and then loop x, and then x is equal to x plus 1. Okay, so the way this works is if I run this function, and then you can call this function something like this. Let's look at the first 2 lines there. For I in 4, print I. Right? So this is how I'm calling, so I'm putting that function as if it's another list that I can loop over in a for loop, or as if it's a dictionary or something, right? But I'm not giving a list or a dictionary, I'm instead giving this function. The way this code works is, first time around, I will be set to the output of this function. And then it will go inside and run that. Next time around, this function will be called again, and the output of that second call will be set to I, and then it will go. Then it will call the third time, the 4th time, and so forth. So each time, instead of simply advancing it to the next element in the list, which is what I would normally happen if I were to do a list here or a dictionary, instead this function will get called, and the output of that function is what I will be set to. And let's walk through this code, see what happens. So the first time around, 4 will be called, and what happens? 4 gets run. So initial x is set to 0, okay, while x is less than 4. Okay, 0 is less than 4, so it is true, so I go inside. So then I print this, and that's what you see there. In generator, x is equal to the value of x, 0. So that first line will get printed. And then yield x. Yield is like a return statement with a subtle difference. If this were return x, the value of x, which is at this point 0, right, will get returned. And that's what will 4 will get returned. So in other words, I, coming back to the calling mode, this is the function, this is the where I'm calling it, right? So I will get set to 0 because that's what function returned the first time. So now here I see I am printing, I go inside this loop with a value of I 0, and then print I is 0, and that's what you see there. That line right there is what is printed by this one. Now I will go and call 4 the second time. And this is where the difference happens. When I'm calling the function the second time, the execution will not start again from the top. Execution will resume from where I yielded last time. Last time around I yielded here, right? So the execution will continue. And at that point when I did, x was 0, right? Now you go here and x is 0, so after this statement x becomes 0 plus 1, 1. And then it will go to the while loop, and it will keep running until it hits another yield statement or a return statement. So x is 1, and then x is going to go around here, 1 is still less than 4, then I'll print in generator x equal to 1. That's that line, right? And then x is now 1, right? And then I yield that. In other words, I return that to the caller. Caller, now, so x is, I will now be set to 1 now, right? So as you can see, caller is running, the function is also running, and at some point this guy will stop and give you the output of that one here. And when he receives the output, he'll run, and then he'll make another call later. So they are running in conjunction with each other, right? So next time around I is 1, and then I'll print 1, and that's the output you see there. And then I go to the for loop and call 4 third time. Third time, again, it will resume from the last call. Last time I returned from this line when x was 1, so this will run, x will become 2, and 2 is still less than 4. So I'll print this line in generator, x is equal to 2, that's that line. And now I'll return 2. Right, so now caller comes here, I will become 2, and I'll print 2. And that's what you see there, 2, the number 2. And then 4 will get called again for the 4th time, and then it will resume from here. Each time this function call will resume. So 2 becomes 3, and then 3 is still less than 4. So in generator x is 3, right? And now I return 3, and 3 will come here, and I will print 3 here, and then 4 will get called again for the 5th time now, and then it will go here, and this was 3, so 3 becomes 4. 4 less than 4 is now false. So I come out of the while loop, and therefore I am not returning anything, so it will return nothing, or none, to I. So I will now be set to none. And when I is set to none, that's a clue to the for loop that I have exhausted this loop.
So by using yield, are you allowing yourself to define x as 0 within the function, but it doesn't get reset to 0 every time you're
Only one
doing
time,
that, right?
That's basically it. So in other words, next time I call this function, I am resuming from where I left off. In other words, the execution doesn't start from the top again. That's really the difference. Yes?
So within that function, can you have multiple use statements?
Yeah, you can. If you try one of the exercises that will force you to have 2 or 3 yield statements in a function, you can have, yes.
In the same note, within the while loop, you can also increment by 2, so you can get every other element, and not all of them in sequence.
Yep, and that's, in other words, you are now in control of how iteration occurs. I mean, it doesn't even have to be, you can be anything. You can, for example, you can define your depth 4 as something like this: yield 3, yield 27, yield 543, right? First time 4 is called, it returned 3. Second time it's called, it returned 27. Third time it's called, it returned this. And fourth time it's called, it returned nothing because I have 3 lines. And the caller of 4, something like this, you're expected to be calling it in iteratively in a loop. Even here you don't have to. You can call 4, 4, 4 like that without any loop of any kind. You can do that if you want to, but typically most people call it in a for loop because you're expected to be repeatedly calling. That's an iterator. This is called a generator function. You generate your own the next value.
Is generator and iterator synonymous too?
No. Iterator is a more generic term which is used for anything you loop over. I mean, lists, dictionaries, anything you can iterate over. It's an iterator. This is an iterator. Generator is something special. Generator functions. You only apply to functions, and they have a yield statement inside. Okay.
So 4 actually returns the value or an object?
This one returns the value of x each time it's called. When you run it.
Right. I'm seeing something else. I just tried the same sample that you told, def4, like yield 3, first time.
So right here?
Yeah.
Yeah.
And when I run 4, it just say generator object 4 at some location.
Are you putting parentheses here?
I'm just invoking a function. I'm not using it in a for loop.
When you invoke the function, did you put parentheses?
Yeah.
Then it should run it.
It did run, but it returned the generator object instead of the yield value.
Okay.
I have it right here. So.
I can
maybe
I can look at it later. But maybe there is a typo or something, or so. But at a high level, coming back, this is how you can build a generator function with some control over what you are returning next. If all the data is in a list, then it's easy. You just use a regular for loop and you loop over the list or a dictionary. But let's say you don't have that list ahead of time, you have to do some math to get to the next element. That is when you would use something like this.
Actually works fine within the for loop, but when you invoke the function independently just from the command line, it returns.
I see. So maybe this is being a generator function. You should only use it in a for loop.
Yeah.
Yeah. Fine. Okay, that's good to know. Maybe that's what it is. You can use that. Here I'm using generator function. That same for generator function, not in a loop, but using an in operator. Normally you would say to in a list, and this will tell you if this element is present in that list, or to in a dictionary, and it will tell you this element is present as a key in that dictionary, right? Similarly, you can use instead of that dictionary or that list, you can use for to check if that element is present as one of the iterator, one of the generator return values. So this function will be repeatedly called to see if 2 is present. We know the first time it's called, it returns 0. Second time it's called, it returns 1. Third time it's called, return 2. And 2 is 2, so it will return true. And these statements show that that function is being repeatedly called because this statement is printed inside that function, right? It's that line right there. So in other words, you can use it like this also. Another example is 5 in that function. So this function will be repeatedly called, as you can tell from these, and whatever the value that it returns, it will be checked if against 5 true or not. And if it's false, in this case, all the elements are exhausted and there is nothing more that 4 is returning, and you still haven't gotten the number 5, so you got false. So in other words, 5 is not in this generator function. It's not a value created, returned by the generator function. Okay. Decorators. This is building on everything we learned so far and then some more. today. It's somewhat of an advanced topic, and I thought that the textbook didn't really explain it very well, and yet these decorators are very popular. Most of the time, they're very powerful too. So,
Like interior decorators?
mention God, right? It's so easy to get in.
Just a question. So, all these, I haven't seen this in like other languages. So, in real world, where would you actually apply these kind of scenarios?
I mean, for the things that I described, for the generator function, like what
The
we got-
generator makes sense because you want like some non-sequential list of values and all that.
Yeah.
But yeah, just go ahead.
Yeah, I will. Yeah, decorators. The way it works is we learned a few slides before that you can assign a function to a variable, right? We had a def func. You have a def f, right? And then you have some function. You can say a equal to f, right? That's what I did for C to Kelvin, Fahrenheit to Kelvin, whatever. In other words, I'm creating a variable and assigning it to a function. This is possible, right? Just like functions can be assigned to variables, because functions are objects, functions can also be passed as arguments to other functions. Like in this function, I have no argument, but let's say I have an argument x and y, right? Normally we pass strings or integers or whatever to these x and y, right? What we're saying now is, I can pass functions also for x and y, because functions are also objects. And one more. Normally when we run a function, in the end we probably say return x or whatever, right? As a return value, something. You can also return a function. Not the same function, but some other function. So just like, because functions are variables and functions are objects and functions can be assigned to variables, functions can also be A, passed as arguments to other functions, B, returned as return values of functions. That's possible to do in Python, and that's what decorators take advantage of. Yes? One more time? Just like functions can be assigned to variables, you can pass in functions as arguments, like x and y, you can pass in a function. Or you can also return, a return value from a function can be another function. Just to normally we return what, integer, string, something like. You can
So
also
the
return.
normal way, argument in and value out.
Yes.
This way is, you can still do that, but now you're able to do function in and value of that function out.
Function as input, function as output.
Function is input, function is output. So it's another way to compress. It's that shorthand thing, and you're just doing more with less.
Yes.
And compact the code.
Yeah. Basically, I'm saying in this statement at least, you can use functions as input parameters and as output parameters. So let's take and why you want to do that.
And other languages don't allow this kind of thing?
As far as I know, yeah, but I don't know, there are many other languages. And maybe modern languages may have support for this as well.
Well, like Perl, Ruby, Bash Shell, that kind of, the common ones. The usual
And Bash Shell,
suspects.
definitely not. That I can tell. Perl, I want to say no. Perl is somewhat older than Python, but maybe they put something add with it. Ruby may have it, I'm not sure.
In C, we have function to function.
C doesn't have this. You're talking about arguments to a function being another function. So let's jump to an example. Well, before I explain, so let's talk about how some of these are used. It's a way to, like some place where I've seen this used is, let's say you're calling a function like for some debug purposes. Let's say you have many functions in your code, F1. something, F2, another one, right? F3, so forth. And let's say your desire is, anytime any of these functions run, you want to enable some additional logging, or you want to get some debug information whenever you want to time, for example, how long this function took to run, or you want to understand how much memory this function is taking, how much runtime it is taking. Or when this function is running, you want to do certain other things on a different thread to collect some other debug information. Basically, as this function is running, you want to do something else. There are a lot of applications for that. Like debug cases are good examples. Enable logging. You can define a function, you can define a decorator, enable logging. So when this function is running, additional logging is enabled, so you get potentially more debug data. And then once this function ends, the enable additional logging is now turned off. So while this function is running, you want to do something. There are many applications for that. In one place where I have seen is where any function is run, like timing the function, runtime of the function is a good example. Although there are other ways to do that too, just the timing aspect. One example, real world example that I've seen are when functions are running, I want to measure the computer's CPU utilization. How fast is CPU running? How much memory it's taking? What all processes are running? When this 5 lines of code or whatever I have this function is running. Or even what's the machine's temperature? How hot is it getting? Because if there's a heavy code in here, exercising CPU quite a bit, then it can heat up the machine, right? It can be drawing more power from the wall. We wanted to measure all these things as some test code was running. This is my test. This is the actual test. But in addition to just saying this test is a pass or a fail, I want to collect all this rich set of data from the hardware standpoint. How much the processes are running, or even software standpoint, what our processes are running on the operating system. As I said, temperature of the machine, power being consumed from the wall. I want to collect all this instead of just running a high-level test and say pass or fail. Right? You can put all this additional debug collection, data collection into a decorator. And all you have to do is add that one line. Enable logging or enable debug logging, whatever it is you want to call it. You can define that name. And any function you want to do all this additional stuff on, you just add one line at the top of that function, and that's called a decorator. And all this collection of that data, you define somewhere else how that data collection, how the CPU should be measured, how the machine's temperature should be measured, all that stuff in a separate place. And each time you run any test, this is tests actually. You just add that one line. Yeah.
So add is how you call decorator.
Yeah.
Instead of calling, like you call a function with the parentheses, that's how you call a decorator, right?
Yeah.
So define the decorator just like you define the function. It's just a function anyway, right?
That's right. That's right. So with that usage explanation, if you will, is there a question? So then let's go into how to define a decorator and how to use it. Right?
Word decorate is reserved for this purpose.
What is it?
The word decorate is reserved for this
No,
purpose.
it's not.
Oh, we
It's
can
not. You can define just like I have enable something here. This is my decorator here. In this case, I use the word decorate. You can use anything. It's not a keyword. It's not a
But
reserved
you
word.
have to use the at symbol?
At symbol, yeah.
Okay, and that doesn't mean array. I mean,
Doesn't mean what?
it wouldn't be confused with an array. Oh, that's
Array.
Not in Python.
That's
Not in
for-
Python.
That's for array.
That's not
Confusing
So-
languages.
Yes. So in this example, this is my decorator, and it's just another function, and this is what I'm decorating. I'm decorating my function, and in other words, like I described here, each of these are my test functions doing something, and that my function is one such one. And this is really my decorator. And you notice my function is nothing fancy. All I'm doing is I'm accepting a parameter, I'm printing it out. Okay? But this is my decorator, and let's go into what this is doing.
So we have created a function that specifically called you are assigning the function to the whatever.
We are decorating a user's functions with my decorator.
And that's a way to get two functions to run at the same time, that's the purpose of it?
Yeah. And two functions run at the same time is very generically used, but yeah. I'm decorating this function with this, is how you say it. And what you do inside this decorator is up to you. Sometimes you may want to run at the same time as this function is running. Or sometimes you may want to do something before that function runs or after that function. Or just before, not after, or something like that.
So you're linking the two functions
You're
together.
linking the two functions, yeah, in some sense, yeah. So this is my decorator. Let's take a look at that decorator. The first line is easy. All I'm doing is, I've noticed that this function, decorate, has an argument called f. And the way we would use it is, this function, when it gets called, f is basically whatever function you're decorating. Python will do that for you. In other words, in this case, I decorated my function, right, with this. So this function will actually get called with f set to my function. Anyway, we'll come back to that in a minute. All I'm doing here is I'm printing a statement, okay? Assuming that f that the user passed in is a function, I can get the name of that function by saying f dot double underscore name double underscore. This goes back to using double underscores to use some other special system word, and this is another one. If you know the function object f, and if you want to know the name of that function, we say f dot double underscore name double underscore. So anyway, regardless, that's just the print function. And notice that now I have another baby function inside this function. I'm calling that a wrapper func. That's possible to do in Python. You can define another function inside a function.
So by doing that, that's separate than the decorator.
Yeah. This is another function that sits and resides inside that. And that little function is accepting star R's. Do you remember what star meant? Convert into a list, that's key. If you had two stars, you convert into a dictionary. So we have one R here, one star, okay? So wrapper func is my thing. And what I'm doing inside that function, I am doing a print statement. And notice that f, I'm not passing f. F is actually passed to the outside one. So in that sense, f is a global variable for this function, because it's not actually defined here. So it will print that executing whatever the name of the function is, and then it's returning the output of that f. I'm actually calling that f function and returning that. We'll see that how it works in a minute. So that's the inner code of this baby function, the code inside the baby function. And the outer, this line again belongs to the, notice that it's indented at the same level as this one. So this actually returns, belongs to the outer function. So what is that outer function returning? It's returning the inner function, the baby function, the wrapper function. So with this is like a decorator. In other words, I'm decorating this with this, right? The way this works is, whenever users call this function, my function, if I didn't have this line, this one line, what will happen? If I call my function with hello in it, all it will do is it will print hello, right? Simple. But the moment I have this line, what happens is it won't just run and print hello. What instead will happen is this function object will be sent as an argument to this function. In other words, this function will run with my function as the function object. And the return value of this function will get executed. So instead of executing this function, the output of this function will get executed. And the output of this function, or the output of this function, is also another function. So in other words, and what is the output of that function? Wrapper func, right? So in other words, when I call this function is executed. So it's almost like I'm replacing this function with this function, right? Because when you're running something else. That's how decorators work.
Are there libraries of decorators?
Yeah. You can write your own decorators, and people do, by the way. Because, as I said, like enable logging is different for whatever you want to do. You can build your. But Python also has may use some decorators and some modules and stuff. Let me say use this decorator. Yeah.
So whatever in my function, like suppose you have a few statements in there,
Yeah.
you will not get executed.
That's right.
Instead, it was executed by the Docker function.
No matter what you have here, it won't execute. Instead, this will run.
So you do have a choice whether you want to turn it off or turn it on.
Yeah, just by commenting out this line or uncommenting this line, you can control whether you want to run this function actual or this function. So in other words, in summary, this function is replaced, if you will, by this function, right? So let me go to the output is actually in the next slide. I'm going to write that on the whiteboard and then we'll go back to the original slide and talk about it. So the output is like this: in decorate function, decorating my function, okay? And then here, that happens at import time. And then I say my function, hello. Then it will print output as executing my function, and then hello. So this is the code. Is it okay to go for 10 more minutes and then we'll take it? The moment you import this file, what will happen is Python will read the function file from top to bottom as it normally does whenever you import, right? It will see this function, okay, there's a function, it goes to the end of that function. It's not going to run that function until you actually call it. Here I'm only defining it, I'm not actually calling it. So it won't run anything. So you go to the next line, which is this line, and then it will see the word decorate. And then, oh, the programmer wants me to decorate this function with that decorator, right? So what it'll do, it'll actually, because this line is outside of any function, right? This line is the main line, so it'll actually try to execute this function. So in other words, because later when I'm at runtime, whenever user calls this function, I have to run its replacement, right? So in other words, it will call, when it sees this line, it will call my function, it will pass my function to this and actually start running this function. So it will print this statement. That is why, notice that I have at the shell here. So even before I ran into runtime, at import time itself, that very first line ran. In decorate function, decorating my function. F is basically my function. So that line will run the moment Python sees this line at import time. It's going from top to bottom. It sees function, okay, it will skip it. This is a decorator. No, wait a minute, I have to replace this function. So I have to pass this function to that one. And then that is why you see that statement even before runtime, you at import time itself.
Good question.
Import time is like when you press F5 in your idle editor or go to run module, that's when you're importing. When you write a function, you save that file and you say go to run module, and then you're in the shell. Then you type the function name, right? So that line is printed even before you type the function name.
Yeah, on this scenario, the value add for decorate is just to print the function name, but in debugging purposes, you may want to add a lot of other things.
That's right.
And then
I added a print statement here only to show you that this function is executed at import time, okay, not at runtime.
Right. Okay.
But really, yeah, you focus is here. We'll get to that in a minute. So what this line will get run, and then it will see another function. When it sees a function, it's not going to run it. It's just going to memorize, oh, there's a method called wrapper func, so that later if somebody calls it, then I'll run it. So it sees wrapper func, and then it will do nothing. Then it will go to the next line, which is this line. Wait a minute, it's returning the wrapper function, right? So what it will do basically is Python will replace my function with the return value of this, which is wrapper function. So that is what will happen when I import this file. And now I'm at the shell, the 3 greater than symbols. now I type my function with the input of hello. So now Python will run a wrapper function with input of hello. Instead of calling my function with input hello, it will run a wrapper func with input hello. So then these two lines will execute, right? Because that's what is a wrapper function. What is the first one? Executing f dot my name. F was my function, right? So executing my function. And then the second line is return my function with hello as argument. Remember, star args is what I supplied. So in other words, if we return, first of all, let's consider the case where this line was not there. For a moment, imagine there is this not line, right? So all it will do is executing my function, and that's it. It won't print anything. This will be the output. So in other words, I've completely replaced my function, which is supposed to print hello for me. Instead, it's printing executing my function. So in other words, I completely replaced it. This is, you can do it. People don't use it this way, but it's possible to do it this way. Under the hood, you can replace completely one function with another, so that at runtime, when people are calling function A, function B will actually run. So that's possible. However, most people don't do it that way. That can be very confusing if you were to replace one with another. What most people do use decorators is they augment the functionality of the original function with something else. In other words, like I said, when you run the test code, you want to measure the computer's processor utilization, temperature, sensor, power, and all that, runtime, and all that. So you want to correct that while you're running the function. You don't want to do that without actually running it. You don't want to replace it, you want to augment it. So that is how most people use it. But you don't have to use it that way. And this example is also written. Now let's bring back this line, return f star args. Right? So this line will print the line before that, executing my function. And then this line, return f, remember, is my function, because that's what we are decorating. Yeah.
Why did you write the new function? Why did you write that? Why did you write it?
Because that's a good question. You can decorate many more functions with the same decorator. Here I can have my function 1, my function 2, my function 3, and I can use decorate for all of them. If I hard code my function here, and later when I decorate it for my function 2, right? So in other words, function I'm passing is also an argument. It's not hard coded, it's an argument to this function.
My function is an argument for
That's right. In this case. But instead of, let's say I have those two lines, right? At decorate, and then I got def my function, right? Whatever, same thing as that. Now I have another one, at decorate, same decorator, and here I have my function 2, my 2, and same thing, some other function. I can use the same decorator, decorate, and then def my 3, right? In other words, whatever. I'm using the same decorator to decorate multiple functions. So when this function is being running, f is my function. When this is running, f is my function 2. And this is running, f is my function 3, and so forth.
In shell, you are calling my function?
Yes. Yes.
So regardless of what function you are feeding, it's still running that piece, right?
It's still running this guy, right? But I haven't finished. For a moment I said ignore this line, right? In other words, no matter what you call, if you didn't have this line, it will just print that line, executing my function and get out. But now I have this function. What is f? F is, in this case, my function, right? So this line actually will return the output of my function with hello argument in it. So in other words, now I go back and actually run my function, because I'm actually calling that my function with some arguments. And what will that do? It won't return anything, but it will print hello. Because that's, now I actually come back and run this function. Because f is this function, right? That's why you see the other output hello, which I erased it. So in other words, I am running that function now. So in the end, as a summary, what did I really do? I basically added this line to my function. If I didn't have all this decorator business, I just had these two lines in my code, I said, I ran my function is hello, I would have seen this one, right? The overhead of all this is to print this one.
And that other first line, right, before my
And this one, that's an import time. Right. But what you can potentially do is, let me jump to an example.
Oh, that's an import time, is it? Not decorate. I thought as soon as it encoders and decorate, it will print that.
Which line? This one?
Yeah.
Yeah, this is an import time.
Okay.
If you have multiple decorators, then which function will be passed as the output?
That's a good question. If I have multiple decorators, right, which function will be parsed as an argument?
Whichever you invoke, right?
The one that you're doing now.
Here you invoke my function.
If I invoke, when I invoke my function,
hello is
then obviously it's my function. If I invoke my function too, it's the other one. But at import time also I'm printing my function.
So it will print all of
It will print
times.
all of them. Because it will create in memory a replacement function for each of the things that you are decorating. If there are 3 functions you are decorating, and you'll see 3 print statements. Decorating my function 2, my function 3.
But the result will be the same, right? The end result.
Well, it depends on what you're doing. Remember, I'm still going back and calling this function. So depending on what you do in each of those functions,
Actually, you don't understand the application of the side.
Here, so here's another example for an application. This one. Here's an example, right? I want you to write a decorator to prettify output.
Prettify?
Right?
English word?
It's a word for a software developer, yes. So all I have to do is, normally when I say print something method, it will print it. If I say print hello world, you're supposed to print, that's what this will do. But because of the decorator, it's prettifying the output. It's putting a bunch of pound, a bunch of dollar signs, a bunch of dollar. So some jazzy output before and after this function. So, but this jazzy outputting code doesn't have to reside inside this function. It can be resident in another function, like a decorator.
Yes.
So, and in this case, I'm decorating this function, but I can decorate this with any other function, which is printing anything to the output. Like print something 1, print something 2, print something 3. All these, the jazzy part, the decoration part of the, in this case, I'm physically decorating the output, right? That code can be resident in a different function.
Or maybe another way is like if I have, let's say, a set of functions and 10 of them handle like numbers, and if I want to validate the input, I can have a decorator that will validate the input for all those. And I don't have to do the validation every time.
Every time in your each function.
Okay.
Yeah.
Can you decorate more than one function at a time? In other words, can you pass through function one function?
Yeah, you can do that too. Let me defer that for a few more minutes until everybody sinks in. But please remind me if I don't. So this is another example. Like what you said is another example.
So you could do it both ways. You could have one decorator supporting multiple functions, one or more functions, or you could have multiple the other way with multiple decorators coming back to just one function.
I said, but I was let me defer to that for a minute. Any questions on this? This is how a decorator works. So in this case, I am doing something before and something after my actual function. And because that part of the code is separated in another function, I can repeatedly use that on any function that I write. Right? So this is another example of a decorator. Do I have any more? I guess that's it. So here's an example. Here's another example, right? Many decorators are very powerful. Often used. Most of the time, though, you are using someone else's decorator, especially if you're writing code or learning, starting to use Python. You're likely to be using someone else's decorator more than you writing your decorator yourself. But then, if you have to, that's what it is. Yes.
Now, what I didn't understand is, since how is it that you could print something after hello world? How could you decorate that? I can see that the first part before, But then the hello world is done once you're coming back from executing the operator, right?
That's what the homework assignment is.
What?
That's the homework
That's what the
assignment.
homework is.
Oh.
But I can give it away.
Oh, so basically I guess what you're doing is you're passing some information to the function.
No, it's actually it's much easier. All I'm doing is here I am printing something before, right? And then I'm returning. So this something before can be the first part of that output, and then I can call f or star args, and then after that, instead of returning right there, I remove the return. I can print some more after that.
But you could also do it in the calling function. I mean, you could pass the information to the calling function. You define the function.
No, you're not allowed to modify the calling function.
Okay.
You're only allowed to write the decorator.
Okay.
So that way, what you would do is that wrapper function, the inner one you got right there, right? So you would wrapper, right? You would put all these pounds and dollars, print of these, right? Print this, and then call that function, and then again print dollars and print pounds.
That's right.
So that way, you print some jazzy output before, then call the actual function, and then do some more after. So I want to go back to the question that two people have asked. Right now, this is getting advanced, but in this case, I mentioned earlier that you can call multiple, you can use the decorator on any number of functions you want, right? The opposite is also true. On the same function, I can use multiple decorators. In this case, I only have one decorator, right? But let's say I have decorate 1, decorate 2, decorate 3, 3 decorators. I can put all 3 decorators right here. At decorate at decorate 2, at decorate 3, presumably, I don't know, this will, in that homework assignment where you're putting dollars and pounds, right, as an output, maybe this will do dollars, this will do pounds, this will do at symbols or whatever, different kinds of decorations. You can potentially do this too. Then the question becomes, which of these 3 will run first, and which is it this one that runs first, or is it this one that runs first?
Is it run bottom?
I don't remember the order. I have to type 1 and see, but it will do it in one order, and it will do all 3 of them. So it will, basically what it will do, I think it will go in and out from out that way. So it will take this function, decorate it with this one. The output of that one it will take and decorate it with this one. The output of that function decoration it will take and out decorate further with this one.
Oh, so it's
So in the end, you let it, yeah, it will cascade. And that is what will run when people say my function hello.
Do you know any popular libraries of decorators that exist?
Not system level, but I do know many things we use at work where we use decorators.
Like open source ones, especially ones that would do things like logging.
I don't know. Okay, so this is very powerful. I think you want to be in the know of what it can do.
Is there any significance to the way you wrote decorator 3, decorator 2, decorator 1 rather than 1, 2, 3?
I mean, it doesn't matter how you wrote it. The question becomes in which order it will run. Which one will run first? 1, 2, 3, or 1, 2, 3? Which one?
So how would you know?
I said I don't remember the answer. You can check it out, or you can quickly build a decorator and see. I think the order is it will go this way. That's my guess.
Meaning what? Closest to the
decorator. First one will run first, and then this and then that.
So is it nested then? Are the decorators nested?
I wouldn't say decorators are nested. It's
to that function.
Yeah, this function can be cascaded, perhaps is a better word. Yeah, you can cascade decorators on top of a function. Yeah.
So you'll always have 2 parts to this decorator. The first part that gets passed on the shell.
Yeah. Even this one?
Yes.
Yeah.
So that will always.
That is what you will actually use. But the guy that, the workhorse that actually runs is the inner function. So this is at the very, what I would want you, each of you to understand here is not all the details, but at a high level of what decorators can do, right? If you get that one, take that for, that's good. In other words, all I'm doing is I'm almost replacing a function with another. Typically, most people don't replace it, they augment it. They do something on top of it. In this case, I'm adding another line here. In the homework case, I'm outputting some extra output.
So when you say the inner function, is it like a function inner function?
Yeah, function inner function.
Function inner function, and so that's what, does what, call the decorators? What does the inner function do compared to the outer one?
The inner function is actually what will run instead of this one. But the outer function is called the decorator.
The outer function is the decorator.
Yeah. Okay? So,
no, it's not okay. No. Clear as mud.
Yes. It's, I thought in the textbook it wasn't well explained. So, feel free to ask me any questions if you have. But at the very least, just get what it is. If you're not too clear about it, it's okay. Or maybe if you try the exercise or two, that may clear things up. But today we looked at functions, different options there are with functions, what are flexibilities you have, and so forth. So it's probably a good time to take a break, a lunch break. Let's meet at 1 o'clock. And while you do, if you can keep the door closed, the afternoon when it gets hot, hopefully it will keep the... Any questions on anything we talked about in the morning or earlier? So like last week, if you want, I can allocate the last hour or something. So if you want to try something, you can kind of talk about that.
Yes, please.
Okay. So I want to then start this file system. So we finished before I go there. There's a bunch of homework assignments that you can try in the coming week. The exercise what we've done so far.
Wasn't that homework for months?
What's that?
Wasn't that homework for months?
I try to give more so that you have something to keep you busy.
Actually, I have to say thank you for giving a lot because it'll give us stuff to study after this.
Yeah. And it used to be that I would never give the homework solutions. I would spend a lot of time in the following class talking about the solutions, but I would never actually give the homework in an attachment or a file. A couple of quarters ago, I changed that because what I was worried is if you didn't miss it. What I noticed is when I'm talking, everybody is feverish to writing it down because they're not going to get it anywhere else. And paying less attention to actually what I'm saying here. And just trying to talk, what is it, R or K? So then I figured if you have it, you're all adults, I shouldn't be controlling you. If you want to learn, you'll learn. I want to talk about file systems today, right now, right? So just a quick summary, what did we learn so far? We learned about 3 data types, right? And then those are lists, dictionaries, and strings. And then we talked about functions today. And then controls, control loops, if statement, generator, function. And then we talked about functions in this morning. What are options with the way you can pass in different arguments, default values, generator functions, decorator, and all that. So the next part, the next hour or so, is going to be about file systems. I mean, so far we've been living in Python pretty much. Dictionaries, lists, everything. You write a function, you give an input. But in real world, whenever you have to deal with anything, you have to deal with operating system, right? Whether it's Windows, Linux, or whatever. Because all the files, people put their files on the computer, on the hard disk, they get stored on the computer's permanent storage. This is an interface for Python to access those files, to read the files. For example, if you look at anyone's computer on the right on the desktop, you'll see a few files, right? You want to be able to open them, read them, close them. You want to be able to create files, you want to be able to append files, write files, and so forth. Python supports all those operations. Here's a 3-line code where you're opening a file, reading a very first line in that file, and closing the file. Right? So if that whatever was in line number 1 of that file, you will see it in the variable. You get saved with your variable line as a string, and if you say print line, you will print that out as a string. So what I'm doing in the very first line, file object. You can name it anything you want. I named it file underscore object. Open is a Python method to open a file. The file name is myfile.txt, and I'm assuming that that file is present in the same directory from which I started Python. If it is in a different directory, you can give the complete path name. C, if you're in Windows, C drive, my document, blah blah blah, whatever. You can do all that. And remember that if you're giving a backslash like you do on Windows, you have to escape it. You have to do 2 backslashes. If you use forward slash, then there is no need to escape it. So you can give the complete path name. In this case, I just gave myfile.txt, assuming it's in the same directory. And second argument I'm telling is I want to open it in read-only mode. Meaning I'm telling Python, hey, I don't want to write to it. I want to read it only. Can someone guess why Python needs to know that? For example, if I'm physically opening a file, what am I doing? I'm just double clicking, right? I'm not telling Python, hey, open it in read mode or write mode or something. But when I say that in Python, through Python, Python is in the end going to the operating system. It doesn't have a magical way to directly access the file. It has to ask the operating system to open it for me. And then you do that. So, can someone say why I have to open it? And can anyone guess why I have to give the mode?
Because there's permissions on any file, so you have to let Python know what are the permissions of the file and what the Python doing.
Good, good. This is exactly the reason. Permissions. Sometimes, even though the file is there, it doesn't mean you can open it. Maybe it is, you don't have the necessary permissions. It's less of an issue on Windows because most Windows computers are used by the same person per se. So you have all access to everything on the same machine. But if you're in shared machines like Unix environment or something, just because a file is there doesn't mean you have the permissions to open it. But sometimes you may have permission only to read it, but not write to it, right? So forth. So by telling the read mode, I'm telling Python, actually even in Windows, if you don't have, sometimes if you only have permission to read it, and you double click on it, it will say something like read only, open it in read mode. Like when I put the PowerPoint slides on H drive and many of you double click, some of you may see, hey, I can only open this in read only mode. That's what I mean. So you give the, yes?
Sorry to interrupt. Are you stating the permission that you know the file has, or are you changing the permissions here?
No, neither. I'm telling Python to open it for me in read mode for the rest of my program, which means if I do have, me as a user when I'm running this, if I have the necessary permissions that match what I'm asking here, then Python will be able to open it.
What if you don't? What if that doesn't match? What if you have write permissions but you only want to read it?
If I only have write permissions but not read permissions, then this call will fail. Or if I request a write permission on a file that I only have read permissions, then also this command will fail.
So that means you have to know what permissions you have ahead of time.
That's right.
What if you don't put anything there?
If you don't put anything there, it's assumed to be read only, like R. That's the default. But you're right. I mean, you need to know what permissions are available to you before you open it. Otherwise, this open command will basically fail and your program will crash. There are other methods you can use before you do the open to query what all files are there in my directory and give me the permissions of all those files or whatever file I'm interested in. And based on that, then I can decide, choose whether to open it or not. You can do that. We'll see some other OS level commands later that allow you to do that. You can do that too. Okay, so assuming I'm able to successfully open the file, I get something back. The open method returns something called, what I'm calling it here, as a file object. Some people call it file descriptor and so forth. So that's like a pointer to that file. So anything I want to do with that file going forward means for the rest of my code, I have to use that object. I have to use that pointer. Like for instance, second line I'm reading a line from it. Third line I'm closing that file. For each of these, I've noticed that I'm referring to the file object and doing something with it. So that's my pointer. Anything I do with that file, I no longer need the file name really anymore. I need that object. So in the second line, I'm calling on the file object a method called readLine. This is another Python method that you can use it on a file objects, which will read the first line in that file. Assuming, let's say, it's a text file. If it's not a text file, that's a different story. For now, let's assume it's a text file, which means a bunch of English, right? And then it will give you the very first line in that file. How do you define a line? A line is something that up to and including the new line character. What is a new line? Like enter is a good way to say it. If I type this is line number 1, enter. This is line number 2, enter. This is line number 2. So that has 2 words there. So the up to and including the first line, new line is the line. Is what will read line give you. And I'm saying that to the variable called line. You can use any variable you want. And then in the third line, I'm closing the file. Again, accessing the file object and saying dot close. So in this little example, we have 3 methods: open to open a file, read line to read line, and close to close it. Any questions on that? So this is how you can open files on the machine.
So are we downloading the content of the file or we just reading?
What do you mean by downloading it?
Like, are we creating a copy? Like when we read a data file in other programs, we can actually read it and get a copy, right? So
Yeah, this is like a copy of line number 1.
just line number 1.
Yeah, and you can do it repeatedly to get line 2, line 3, line 4. And there's more methods you'll see in the next few slides, which you can read the entire content in one shot. Here's another example, similar one, for writing. Same thing, C drive, I'm giving a complete path file now, path name. And notice that whenever there's a backslash, I use 2 backslashes because otherwise backslash means something else in Python, right? It's an escape character. And second argument is W, meaning I want to use this for write purposes. The previous example was about reading. And therefore, the second line, you can see, I'm writing a string, hello world. And then I'm closing the file. So these 3 lines will basically create on your My Documents directory on your Windows machine a file called My File, and it will put 1 line of text in it. So after you run this program, if you use Windows Explorer and go to that directory and open that file, you will see that string in there. Okay, so that's a simple read and a simple write. Now there's another method. Now for the next few slides we'll talk about what all flexibilities there are, what all other methods there are, and so forth. Look at this example. Open the file the same way as for the first one, read more. And in this case, my file is what I'm opening. I didn't give any extension or anything. And in the second line, I have a method called read lines, the plural. What this will do is it will read all the lines in that file, the entire file. So you want to be careful when you call read lines. If the file is very, very, very large, this can be locked. This can take a lot of memory. So this will basically get a list of all the lines. So each line will be a string, and it will be a list of strings. And that's what it will return. And what the len of that will do?
Tell you how many characters are in the line?
No, this is a list of all the lines. So it'll tell you how many lines there are in that file. And then I'm closing the file. I'm opening the file, printing how many lines, calculating and printing how many times lines there are, and closing the file. That read lines will basically give me all the lines, right? As a list of strings. It's another way to get to the same answer by using a little for loop. For first line is the same. I open the file and I put a count to 0, and then look at this line. For line in file object, count equal to count plus 1. So what this will do is it will repeatedly call file object and get the next line in that file, and then set it to a variable called line. But I'm not doing anything with that variable inside the loop. All I'm doing is incrementing the counter. So this will do the same thing. As at the end of the file for loop, I will have the number of lines in that file I'm printing down here. And the interesting thing is to notice the structure of the file for loop. For loop, normally we say for I in, and then here we normally give what? A list or a dictionary or a string or something, right? Now you can give, and then at some point we also learned about the generator functions. Now you can also give a file object. So Python knows when it's a file object and you loop over that file object, it needs to give you each time you loop and the next line in that file. It gets it. That it's not a list or it's not anything like that. So that's pretty powerful. It gives you next line, next line. Instead, in fact, if you put inside this a print line statement, right, maybe before or right after this count equal to count plus 1, it will print you every line there is in that file.
You can have an if statement also which all lines to print and which not.
Yeah. Basically, you look through it, you get the next line, next line, next line, and what you want to do with it. So
Is that because file object is actually a list?
file object is not a list. It's another data type. But the smart thing is Python knows that it's a file object, not a list, and yet it will do what you will probably want it to do when you loop over it, which is to give you the next line, next line, next line. So that way it's pretty smart. It's doing what you probably want to do, and it's putting the syntax of Python, syntax that you will want in a nice, easy, concise way. That's where the language power shows, right?
Is this something very much used for log parsing?
Yeah, yeah, absolutely. You want to parse a log or something, or anything. You open a file, you loop through it, and keep finding what you want.
A great method for automation, right? Something if you want to search in a file and then.
Yeah, absolutely. Yeah. Yes.
So for my file, that is the location of the file.
Yes.
The file name, like whole file path.
Yeah. Look at the last example. C drive, my documents, my file application.
You gotta be like double last. Like double.
Yeah. Yeah.
So if I want to just look at top 10, top 100 or top 10 lines,
Yeah.
should I just say while line less than 100?
While count is less than 100.
Count.
Right?
We use a one line. We use this every for everything. I mean, not this one, but
Yeah.
All kind of file.
Right now we're talking about text files.
Text like any like Word or any.
No, Word is not a text file. Word adds a lot of formatting, color, blah, 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 font size, blah, blah. But in Word, you can save it as a text file, right? Text file is what you open with the Windows Notepad and you start typing and save it. Text file. There's no formatting or anything other than text in that file. We'll talk about later binary files as well. So,
you can read only through the text file, or there are some other ways?
some other ways. What?
As in, can it only read the text?
No, it can read non-text file also. We'll see that in a minute.
So So open and close has to be included, right? Otherwise it will give an error.
Yeah. Well, if you don't open it, it's not nothing else will work anyway. You have to first open it. Closing the file is a good practice to do. It's not really necessary because if you don't close it, when Python exits, operating system will close it for you. That's true of any languages, not just Python, but it's a good practice. You should close it. Write method. Write method will write whatever you give into that file. It's not going to add any new line character or anything. You have to do that yourself. If you say my file write hello, it will write HELLO. That's it. Those 5 characters.
Maybe put a slash n after hello.
Then it will add the new line character. Yeah.
The next line will be written as a, on the next.
Yeah, yeah. So the way it works is when we're there, let's say you have a file, right? So your file pointer is pointing to this one, the very first character, right? So when you let's talk about read line, the one before. What happens is the first time you read the line, you call, or even, first time you read it, it will read the first line, and the next time you call read it, it will read the second line. In other words, file pointer, third time is the third time. Each time you read you don't get the same string. In other words, as you keep reading, the file pointer will be updated to point to the next character in the file. So, do I have an example? Same thing when you're writing as well. After you write the first line, let's say, then file pointer will automatically point to the next byte. So if you write again, it's not going to write over the spot you wrote before. Yes?
Before you work on the file of those, do you have to import any import files?
No.
No.
Question. On that, go back to the previous page. On this scenario, when you do the write, hello, if you don't put the \n, the next write will go continue on the same on the same sequence.
That's right.
It will overwrite it, right?
It will not overwrite.
No overwrite. No, after the hello.
It will never overwrite it.
It will append.
But if you want the whatever you write after that to come in the next line, you want to add a /n. Okay. If you want to write whatever you line right after the character O, then you don't need to add it. You should not add it to line. Similarly, just like read lines, there's also write lines where you can give a list of strings and it will write all of them one after another into the file. Here's an example of making a copy of a file into another file. The first 3 lines, I'm reading a file in and then next 3 lines I'm writing into a second file. So first line, I'm opening the file in read mode, and then input file read lines, which means I'm reading all the lines in that file into a list of strings. I'm calling that lines. And I'm closing that file. So in other words, the entire file is now saved in the variable lines in the form of a list of strings. And now I'm opening a second file for write mode, and I'm using the write lines of that variable lines here, bringing that here, and I'm writing all those write lines into the second file, and now I'm closing this file. So now basically my file and my file 2.txt are exactly the same. Taking all the files in one line, put it. There's much other ways to copy the files, by the way, much easier ways. But this is just one. This is one way. If you want to copy a file, there's other ways to do it. Other easier ways to do it. This is how to read binary files. Notice the character B. What are binary files? That's how you say it's a binary file. What are anything that's not a text file is a binary file. And let's say if you have a Word document or a PowerPoint presentation or some other or something, all those are HTML file or anything. All those you can think of them. Actually, HTML is probably not appropriate because it's text. It's binary files like Word or Keynote or PowerPoint or any of these. When it's a binary format, there is no concept of a line anymore. Line means it has a special newline character. But when you have a binary file, there is no concept of a line anymore. So when you read binary files, you read them in terms of bytes. So the second line here, I'm opening the file in the first line, and the second line, I'm reading the first 4 bytes of that binary file. I see the number, you see the number 4. Those 4 bytes will be saved into header. And then when I read something without any arguments, 4, then that's reading all the rest of the bytes in that file. If I don't give anything, it means read everything. So the way this works is, let's say you have the binary file. So first line, and initially when I open the file, my file pointer will be here. And the second line, I'm reading 4 bytes. 1, 2, 3, 4. So all those 4 will be saved into a variable called header. And now my file pointer will be pointing to the 5th byte, right? And so in the third line, when I say read with everything with no number in it, from 5th byte all the way to how many bytes there are in that file, all those will get saved into the variable data. So the first 4 bytes in one, everything else in the data. Any questions?
Question.
Yeah.
Is there a limit on how big this file can be? Because I mean, this variable could easily run out of memory.
Yeah, there's no limit. It's your job to be kind of watching it.
Okay.
If you think file is really, really, really big, and you say read, and which means you're forcing Python to read the entire file, that can slow down your computer very fast. And OS will have some ways to manage that. What it will do is instead of putting everything in memory, we put some on the hard disk, and we call it paging. But it will slow down the CPU.
Well, this method will work for reading the lines. Let's say import underscore file dot line 4.
No, if you know it's a binary file, then read line will not work. Basically, what will happen is,
assuming it is not the binary file. Well,
yeah.
So if we pass the parameters of the lines, like 4 or 2, will it read the first 2 lines?
No, there is no such thing. Yeah. You have read line, which will read the very next line, or read lines, the plural, which will read all the lines. If you want the first 4 lines or something, you have to do that yourself. Yes?
The binary file is like any file, like PowerPoint, Excel, anything.
Yeah. Anything that is not a text file. Okay, let's go on to something else beyond. That's about basic file systems, right? How to read files, how to write files. By the way, there's many other things that we're not talking about here. For example, in this case, I'm reading or writing, right? There are many other modes as well. There is something called write plus, append mode, read plus. You should refer to the documentation to see what all it means. In particular, there's an append mode. What is an append mode? Append mode means I want to write to that file, but I don't want to create a new file. I want to append to the end of that file, which is a lot of times that's right. There's probably 10 lines in there already. You want to open that file and add 11th line to it. You don't want to replace line 1 or you don't want to start off. So that's when you would use append mode. Sometimes you want to, if that file is there, you want to delete and create a new file with the same name. Then there's a mode for that. A few other things like that.
How to override it?
Yeah, they override it. That's what I just said. You delete that file and you write again. Create a brand new empty file with the same name. That's overwriting, right? we've already seen this one, input. This is a way to prompt the user to give you an input, right? Same thing here. You enter your whatever you prompt him, and then you can later convert it into integer if you want, int x. But the high level point is there is standard input, standard output, and standard error for every process. These are specialized file objects. And Python, you can access each of them using sys.standard in, sys.standard out, and sys.standard error. Let's take an example. In this example, you have, let's follow up through this code, right? Import sys.standard out means sys is the module name called. So the second line, I'm saying print write to the standard output, right? That'll write to the standard output, no big deal, right? You can also, another way you can do that, by the way, is sys.stdout.write. This is like accessing the standard output channel and sending a write method. Basically, standard output is also like a file object. Just like files you can read and write. These channels also you can, in this case, standard output you can write. It works the same way. In fact, print will do that. That's what print is doing under the hoods. So you'll see the same thing. Just like printed to the screen, this also prints to the screen. Except it also gives you a number, which is basically the number of characters that it was able to write to the output. Okay. Similarly, in standard in, this is like the equivalent of input command, right? This will accept input. I put it in red color so you know that's what user type. So whatever you type will be saved into S. So later if you query S, you get that. One thing you can do with the standard output is more fundamental, right, than print. You can redirect the output to something else. Let's walk through the code to see how we're doing. I'm importing a module called sys, okay. Then I'm opening a file called outfile.txt. I'm opening it in write mode, which means I want to start writing to it. And then what did I do? I redirected the standard output to that file. So from now on, whenever people are writing to the standard output, it will actually go to that file. It will not come to the standard output. That is what I mean in line number 3, where I say I'm redirecting the output. So okay, that was successful. In line number 4, notice that I'm trying to send something to the output. Write lines, the first line, second line. If I did not redirect in line number 3, this would have produced an output on the screen. 2 lines, first line, the second line, right? But notice that it didn't print anything, it just printed 3 greater than sign, meaning, yeah, I did what you asked me to do, but there's no output to the screen. And look at the print statement. Same thing, I'm trying to print a statement, and nothing shows up on the output. Same thing, 3 plus 4. Normally I would see a number 7 printed on the screen, right? Nothing. Basically what's happening is all these output is going to that file, because I redirected it. This is one way to globally redirect everything from now on. Don't print anything to the screen. It's sometimes useful when you think customers may see what is on the screen. You don't want to show it to him. Instead, you want to send it to a file so that you can use it. So 3 plus 4, it's going to the file. Now I undid that redirection, and this is the way to do that. System standard out equal to a global variable, a read-only variable, double underscore standard out double underscore. Now that redirection was undone. Now if I say 3 plus 4, I see 7 on the screen like I should. So this is one way to globally replace the output, or redirect the output to somewhere else. Print method itself is pretty powerful, right? We've seen a few variations of that, how we can use it. Here's another. Here I'm saying 2 strings, print statement, and then in the end I'm saying file equal to F. File equal to F means basically for this one line only, I am writing these print statements to the file F. This is a selectively It's that once time one print I can send it to a file. Or I can also say f.write of this, right? That will do the same thing. This is another way to do the same thing. It's the print statement, but later when I say 3+4, I see it on the screen, but this one line alone, I sent it to the file using print. So that's about file systems and standard input, standard output, and standard errors. For now, I'm going to talk a little bit about a special module called OS module. It goes in line with the other one. It's very handy OS module. You will want to you should take a look at it. There's some functions I'm going to talk about here. There's many more in the manual. Because it interacts with the operating system, it's very useful. If you want to know the current working directory, you can say get CWD, os.getCWD, get current working directory. For example, I can say, I can start my shell, and so import OS, I have to say, os.getCWD. See, I'm now in C drive Python 33.
What was the first part? Import what?
OS.
Import, just import OS.
Yeah. That will import the module. We'll talk about modules next week. What are modules? Python has a Python, right? The interpreter, that standard thing. But there's many other special things that are encased in modules. And or you can think of it like a library, right? If you want to access some of the things in that module, you can refer to the manual, but before you can access all of them, you have to first import the module. It's already on your computer, so you don't have to go to the internet and download it and install it. But it's not loaded when you start a shell. All the OS modules, and there are many more modules. Sys is another module. There's many things. All those are not loaded by default when you load the shell, but you can load it manually or something by saying import OS. Yes.
You mentioned next week. I mean, next week is when we're out, right?
Next week we're out the following.
So you mean the following week? Okay.
Yeah.
Last week.
Yep.
So can we change the directory?
Yes. You can do that. Have a slide here. You can look up in. I don't remember what it is. It's probably something. CE or something.
How to execute a system command.
We'll talk about that later. So if you want to list the contents of a particular directory, you say os.list there. For example, I can os.list there. If I don't supply anything to the argument, it means I want you to list for the current directory, and those are all the things that are there on my current directory. It's a list of strings, basically. There's a few more, on the next few slides you'll see a few more things. os.path.join is another function which you can give multiple directories and you can combine all of them to build a path. bin/util/list tools for what it's worth. Well, the good thing about this is os.path.join. If you know, if you've used Unix systems or Linux or Mac OS, it's forward directory, forward slash, whereas in Windows it's backward slash. So what this os.path.join is, depending on whichever operating system you're on, it'll construct the right string for you, whether it uses forward directory or backward. That's what os.path.join. os.path.split. Let's say there's a directory like that, user diablo temp hello.txt. It'll give you a tuple of strings. The first element is the string of the directory, and the second is the file name alone. You can get both the directory and the file name split into two things.
So it knows which is the path and which is the file.
Yeah. So it's not hard to tell, right? Everything after the last slash is the file. Another one, always that path, that base name. This will give you the file name, and there's always that path, that dir name, which is give you the directory. The same thing as before, the last one gave it as a tuple of both of them. This will give you one or the other separately. This is separate method just for the base name and just for the dir name.
But you cannot define where to split it.
Yeah.
No, right?
Yeah. Base name, basically it's like you're asking give me the file name.
Yeah. No, I was actually referring to the last example where we split. So here we cannot define where to split.
Yeah. Well, the split returns a two element giving the base name and from the rest of the family. So it's kind of hard coded what it gives. So this is base name and dir name. Here is a split extension. So it will give you a tuple again, a list of a complete list of the directories path as well as the file name without the extension, and then the .txt as the second element. Split extension.
But again, it's not user defined.
Yeah. Yeah. I mean, now you're dealing with file system, operating system, right? It's not just splitting any string. It's splitting a directory path. So if that's the case, your extension is that one, and everything else is that one. It's not like I'm splitting a random string from here to here is one and here to here. That's you do with strings. You don't need OS module to do that. A few other useful ones. You supply a directory path and you can ask is dir. Is it a directory or not? Similarly, is file. And you're going to give a path and ask is it a file or not. If it return true, if it's a directory or a file, otherwise it's false. A final one is often used. What is that path that exists? That path. If somebody gave you a wrong path or user gave you a path, you should first check if that's a valid path on your computer. If somebody gives you C drive, my documents, and then something.txt, and that file actually doesn't exist. And then later on you try to open that file and everything else is a mess. First of all, you have to make sure it actually exists. And this is the way to do that. What is that path that exists?
These are all assuming a local computer read run. What if it was a computer on a file store in a server?
It can just be a path is different. For example, you can, like on this computer, H drive is there, right? It's mounted. So I can say OS H drive.
That's if you have a mount on your local directory.
Yeah, you should have it mounted.
How would you do this if you had to access another machine? Like, would you go by IP address or by host name? Another machine in the network?
Oh, then you will not be using first of all this module. You will have to connect to that machine first, right?
Just connect to the machine, then you'd be in the local directory again.
Then you will. I mean, once you mount it, then it's part of your file system.
Okay, yeah, Linux, you mount the file system.
Yeah.
Okay.
So you can do OS that list the C drive. It's in double quotes. What's that? C drive my document which is not able to find. And then you get some other error. File not found. Is it my document? The space.
I think only one backslash, you have two backslash says it's a server name.
The documents and settings.
Oh, that's right. or I can give you another path, let's say perf logs.
Yes, Python predictory.
Perf logs. There. Similarly, on my machine I had that. An H drive. There. I can give H drive Java, and these were the files or directories in this case on the H drive. So since H drive is mounted on my computer, I can access all those files, even though physically they are not resident on my computer, right? They are on the network drive. Okay, so os.walk. This is pretty powerful. You can give a directory path, and it will walk down that directory to all its subdirectories and sub-subdirectories and everything, and give you a list of all the files. So, for example, if I did os.walk of my H drive, maybe to give you a generator or object, maybe I can convert it to a list or something. There. It went into, there are 3 stop directories, and each of them there are some other files, each of the directories. It will give you the complete listing of every file in every directory using this. You should, if you give a big directory like C drive, you print many files, you should be careful. That's what OS does.
One refers to the there's an empty element. Like week 1, week 2, week 3 powered by empty, and then there's another empty one.
Yeah.
What is that? Is that dot directory or something? Dot. Quite a few of those.
It's giving actually, it's a list. You can see it's a square brackets, right? And it's a tuple, and in the tuple is a string and another list, and empty, and another tuple. Exercises that
there's a few of those empty ones.
Yeah. I don't know what it's doing. Why there's an empty.
Maybe that's the one up, like the dot or the dot in Linux and Unix.
Probably, yeah.
It's on every one, every group.
Could be. I don't know. Doing something. You can also try for a local directory to see if it's doing the same thing. Let's say C drive, documents, and settings. Or that perf log. So here too, there's an empty. I don't know what it's doing something empty. I'll have to look at that one. But this is pretty powerful, especially if there's a directory structure and you want to print all of them. You can walk that entire directory, and you have many options there too. You want to go top down or bottom up. That you can set this flag to control one way or the other. On error, you want to continue or stop. Follow links. Sometimes you have symbolic links pointing to some other directories. You may want to go to that directory and print out that one too, or you don't want to follow those directories. You should be careful. By default, that's why it's by default it's false. If it's true, you can go to other directories that this may point to, and it may get even more. And sometimes you can have circular loops, one pointing to another directory, and that directory pointing to this one. So you can sit and churn in loops. You should be careful with that. But that's those are some of the examples. There are many other things in the manual, please refer to them. This is just to show you what all is possible when you're dealing with operating system. Okay, any questions on that? A couple of other advanced topics just to show you what Python can do. I don't expect that you'll be using them, just like decorators and generators. I want to show you a couple of this, just to see what it's capable of. Pickling is an advanced topic. Basically, it can, let's say you have written a large code and there are a lot of variables in it, a lot of data structures, a lot of classes, this dictionary, blah, blah, blah. And let's say your goal, I can't think of a reason why you would want to do this, but let's say if you want to save all this into the computer on the file, on the hard disk, into the file system, and have another program open it up, or say open up and read back all the data. It's pretty involved. Right? Let's say you have 20 variables, or how many are, some of them can be classes which have its own instances, members, and all that. It can get pretty involved to save every data type into the hard disk for later retrieval. So it will probably mean if you're not using Python, just to write it to the disk is a big deal. You have to agree on a format to write it. So the read guy and the write guy is doing the same thing. And then just writing the code is probably many pages of code. And then reading it back is similar number of size. You can do all that with 3 lines or 4 lines in Python. So this is what you would do when you're dumping all the data into the file system. What you would do is you'll open a file, and in this case I'm calling it state, write binary mode, and then all the variables that you want to save, you say pickle.dump, 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 variable A, variable B, variable C, and so forth. Whatever you want. Variable A, B, C can be any type. It can be strings, dictionaries, even classes. Your own custom classes with very complicated blah blah blah. All those, as long as it's variable, you can just dump it into the state variable. And Python will save all those, and when you close it, done. This is very similar to file opening and file writing, except you're not calling file.write, you're calling pickle.dump. So it saved all those, and in the opposite file, the later when you want to retrieve the data, all you do is you open the same file in a read mode, and you say pickle.load, pickle.load, pickle.load. So you will get back all the variables in the same order in which you wrote them before. So first you read, you get back A, second read, you get back B, and so forth. So you can pretty much save any of these types. Lists, tuples, numbers, strings, dictionaries of any kind, you can save them. So that's about pickling. Another similar advanced topic is something called shell. It's used for reading and writing files of very large size. And the benefit that this gives you is the performance. It is able to read and write files of large size. For example, let's take a look at this one. I'm importing shell. It's a module. So you put that and you open a file. This is the file you're trying to open. Let's say this is a telephone directory of a lot of people. I'm calling it addresses. I'm opening that, and I can basically access each of the entries or brackets in that book, in that file, just as if it's a dictionary with multiple keys. Book Flintstone is a person, I guess, presumably the last name is Flintstone, and here's the name, first name, phone number, the address. And here's another person, the name, phone number, and an address. So I saved it. I closed the file. So essentially, in this case, I created 2 entries in that file, right? And I can read it back later, open it, and then I can, just like I would access a dictionary, book of Flintstone would normally give me the value of that key Flintstone, and the value is this one. So this is like a dictionary, but I'm actually writing to a file. That file is addresses. Normally when you read dictionaries, it's not present to the file, it's on your memory, right? Here I'm writing to the file, and yet I'm accessing it, reading and writing to it as if it's a file. The only restriction you have with shell is the keys have to be only strings. You cannot have anything else. Okay? So that's that. Someone was asking me earlier how to. So that's about this. Next few slides I'm going to talk about something called subprocess. This is actually pretty important. if you're writing any code that deals with the operating system, then you need this. If you're dealing with the file system portion of the operating system, then we already talked about how to read a file, how to write to a file and all that. Let's say if you want to issue a command, like the command that you would normally issue at DOS prompt or Windows Unix shell prompt, you want to run them from Python, right? For example, in Windows, can someone tell me what some of the Windows commands? Let's say I open a terminal and I say what?
dir.
Dir will give you the list of all the files.
CD.
CD will give you a PWD. Will give, these are all PWD doesn't work.
I think that's a.
CWD.
I think that's Unix.
So PWD is Unix.
CWD.
CWD.
No, CD without an argument doesn't move. CD with an
yeah,
argument
CD without
moves.
an argument will give you the directory you're in. CD with a space and new directory will give you. So all these are operating system commands, right? And there's many more. Maybe if you do help me.
CHKD.
So these are all the commands. If you want to rename a file, you can use rename, replace, remove a directory, a whole bunch of things. You can set a time, right? Copy and so forth. So each of these, and there could be many applications themselves that you can run. Like any executables, you can run on command line, right? All those are considered a command, if you will. If you want to run all these from Python, you can do that. And that's often useful, necessary even. That's when you would use a module called a subprocess. It used to be that there are few other commands, but they're now deprecating all those things and suggesting everybody to use subprocess. So what you would do is pretty simple. You would import subprocess and subprocess.call. You should refer to subprocess module direct documentation to see what all you can do. But here's my example, .call, and here you will give the arguments, the command that you will actually write, you will actually run, and then this command will run for you. For example, I can say from the Python, I'll say import subprocess, and then I can say subprocess dot call CD. I think I have to shell equal to there. Run it again. So I issued the CD command. There's a few arguments you can pass. You can read about them. Shell command, you say shell equal to true, and then you can say something like, what else? Does echo work in Windows? Oh, it does. It does. So it echoed something, whatever I asked him to echo. So in other words, I'm able to run operating system commands or any executables. Sometimes
you run system info.
Is there a command?
Yeah.
And the first test is what is it? System underscore
info.
Like that?
Yes. No, don't underscore, all one word.
Oh wow, what did you do?
It just calculates. It looks all over and then it prints a list of model number and the memory. And
yeah. Let this complete. We can run it on the other side, or while it's running, while it's beginning. So I can say system info. Okay, doing the same thing.
Yeah.
Boom. So this wider one is Python, the back one is DOS. So it gives you the same thing pretty much. So now from Python you can issue all these commands, and I notice it's giving you the host name, operating system name, a whole bunch of things, processor types and all that. You can now parse it. For example, you can say A equal to all this. And all that.
So you can find out anything you want from A.
A didn't get all that. A is not the standard output. It went to the standard output, yeah.
Oh.
You can save the standard output to a variable or save it to a file or something and open that file, parse it or something like that. Or, so at a high level, from Python, you can issue operating system command. Often very useful. So that's a call method. There's a few other variants of call as well. Check call is another. It runs commands with arguments. Wait for the commands to complete, and if the error code is return code is 0, otherwise I raise an error. Okay. The variants are about what to return, what to do in the case of an error, and so forth. And notice there are many other arguments, like std in, std out, std error. Remember, each process has, you can control all that. You can send input from a standard input or a file if you want, or redirect the standard output to a file or something. Same thing with standard error. You can issue a timeout, and you can tell if it should be run in a shell or not, or something like that. So each of those you can change. Check output is another similar one. You can create it. Popen, it opens a process. All these commands, you type something and you get a response, right? But there could be something where you start the process and it will keep running for the next 20, 30 minutes or whatever you want. Or it may keep running until you kill it. But you don't want to wait on that. You want to start the process and go do something else, right? Asynchronous execution. Popen is good for that. You start a job and then come back to Python so that you can keep running the rest of your code in Python, while that process that you started is also running on the side. And later you can go kill it. You can wait on the process. You can pull the process if it has terminated and all that. But to better understand some of these, it may be helpful if you take a class on computer operating systems. You can undergrad class on operating systems. They talk about processes and how to fork a process, how to terminate a process, how to start one, how to all those you can. All I'm saying here is you can do all that in Python. You don't have to go away from Python in order to do all that.
Will the Linux class here kind of go over all this stuff? Not really.
I have no idea what that. You can check with the teacher.
And do you know if a Linux class?
Yeah, they cover that for Linux, the regular command line.
How closely applicable is it to Mac? Pretty,
Mac?
yeah, pretty applicable, right?
Yeah, Mac is basically Unix, right?
Probably
And Linux is
90%.
basically Unix, right?
Yeah.
They're basically the same.
It should be the same, yeah.
It's about 80–90%.
Yeah.
Where can we use this kind of in a real
Oh, where can you use this? All the time. I know somebody at some point asked, they wanted to tie in Selenium. They were taking a class on Selenium, which is basically going to Firefox browser or Chrome browser and clicking something, right? You can start Selenium process from here. I mean, why? I mean, for example, if I want to play and I want to start, let's say, Windows Word, Word, WinWord or something, right? You can do anything.
So what would be the most kind of popular usage of all that process stuff plus Selenium?
Let me finish this one more.
Oh, sorry.
So, for example, let's say I want to start Microsoft Word from Python. That's a useful enough thing, isn't it? So, location. Where's the shortcut?
That's just a link to start and try a notepad, it'll be easier.
Oh.
Just a notepad.
Where is that? It's an accessories.
I think this is in Windows
Right
65.
Yeah, right there.
Type in just search it and find it for you.
So Windows, I think C drive, Windows 30, System 32, Notepad. Or let's can I say this? C drive, Windows, System 32, Notepad. Okay, right? So that works. So I can now, from Python, start that program. C drive, Windows, system32 notepad.exe.
Let us skip.
There. I was able to start Notepad. Notice that since the Notepad process is running, notice that my Python is still running, it's waiting on that. Notice that I don't see a triple greater than sign, which means I cannot issue any more commands until that process is running, while that process is running. But if I kill that one, now I get the triple greater than sign. So in other words, it's synchronized. Well, until that is killed, I can't do anything. Let me do one more time. See, now there's no greater than sign here. I'm waiting on that. My cursor is blinking at the bottom left. But once I kill it, then I get it. But what if I don't want to wait on that? I want to start Notepad and go do something else. Then I'll do topen. Notice Notepad is started, but now I can issue other commands here. A equal to 5 or B equal to 7, C equal to 4, whatever I want to run Python, subsequent ones I can run it. And this one is still running, so forth. So a lot of controls you can do.
And you can also run the Notepad with a parameter that opens a file. So you can pass one of those arguments.
Yeah, and you'll open that file.
And it'll open that file
yeah,
for you,
yeah,
and then you continue.
Yeah.
Why do you put shell equals true at the end?
Oh, for certain things you should refer to the documentation. For some of the operating system commands, you have to give shell equal to true. So Python will actually start the native shell of that operating system and run it in that one for you and give you the output. Certain other things you can, especially the non-DOS command, you can run it directly. So those are some of the few things we can do with Python. Like, sorry, you were asking a question earlier with some Selenium.
Oh yeah. So how do you combine all that system process stuff with Selenium?
How do you?
Selenium is just like clicking on the browser.
Yeah, but then you will make a script, right? Right. And then how do you run that script? What do? You have to open Selenium app and then go there, load it, and say run.
No, you just run it through the command line. You save a file with your whole script in it, and then you go Python name of your file.
Python or Selenium? You run.
No, Python. Because you can't run Selenium by itself. You need to have another language. Like
I see.
So
Okay.
you run it with Python or Ruby or Java or whatever, or
Okay.
you run it in a test runner.
Got it.
Like
So,
Python.
well, if you can run it in Python or Ruby, you can, in this OS subprocess.topen, and then you will give Python, which will start a second Python shell to run that Selenium.
So that
or
will allow you to do other things while that's running?
Yeah. Or you may want your top level file to be in Python, which will have 10 calls to each of the 10 Selenium things. So your top level is a Python file. So, yeah.
Okay.
Or you can go to other things. So,
Thank you.
so that's about file systems.
And you have to put 2 backslashes for every directory, because that's, in Windows you only put 1 for each one, but you're putting 2 backslashes.
That's
Why is
when
that?
it's backslash, because in Python, remember, backslash means something else. Backslash doesn't mean backslash. It's a meta character. Backslash is used for escaping the next character.
So you have to tell it, don't think it's a backslash.
Yeah. To do that, you need two backslashes. For forward slash, you don't need to do that. So that, in a nutshell, is what the file systems and dealing with the operating system is about. Any questions on that? Let's take a 10-minute break at this point. 2:15, right? Maybe I'll do something until 2:45, 3 o'clock, and then I'll be around for any questions or answers.
Can you put the command back up the window? Yeah, again, I got another error, but I typed that same thing and I missed it somehow. Different language.
No, I said if you try to open a really large file, then operating system is not going to have enough memory on your computer to load all that file. Then what you do is you put some of that file on the disk and some in the memory, and it'll, and then you do something, you can page it.
Okay, so
That's an OS concept,
that's an
it's
OS
not a
thing.
Python thing.
For memory paging.
Yeah.
Okay, not part of Python. Okay.
But all I was saying was, don't try to read the entire file if you know the file is very large.
Because you'll start to use them like that, you get into memory paging, which could slow down what you do.
That's right.
Right, this guy around, this is what I did. It didn't, but it finished for the end. So this is what it does, it creates this document, right? And then it is trying to return the file. But it goes here and opens up this, and then it tries to have the file, and it's supposed to, like, probably it shouldn't be clicking on this button and having this window open, it should stop here, right? And then take it kind of through the back. But anyway, it,
OS.R. Did you say import OS?
Yes.
And then, because OS we used to have about module not, which is not all of it.
Can it not find it?
No, what do you want to do? OS.R?
Maybe I'm using the wrong thing.
What is it you want to do with that file?
I want
order number at least.
So watch, if I go by myself, I
You
can
know your friend's email address if you want to
attach that file to this document.
Yeah.
That's what I wanna do, I wanna attach that.
So what you want to do, your Selenium is, you wanted to, I don't think OS.path will do that for you.
Okay.
What you want to do, you want to in Selenium with that.
Right.
Then here, file name tab, you can give that entire, you have a way to type it, right? In Selenium.
No, you don't, Selenium cannot see this window. That's my whole
Oh.
point, Selenium cannot see system windows at all, like, they don't exist for Selenium.
That's your problem.
That's the problem. If it could, I could just click, click that,
Yeah.
right? That was my whole point with that, remember,
But
about the
then
thing with
OS
the coordinates?
Yeah, but in that case, OS.path is not going to help you.
What will? Like, there's a way to choose, find a file kind of through the system, find it, and say I wanna use it.
No.
No?
No. I mean, this is app specific, how we have to give an input to your application, right?
Yes.
How do you do that? You have to have a way, you mean the app, has to have a way to feed it to you. Or sometimes these file dialog boxes are generic. Maybe Chrome may have a backward way to pass that to you. But Python is not going to be able to do all that by using any number of OS or whatever.
You can't?
No. You have to be able to find a way to type it here.
Can't Python type it there?
Not Python by itself, but there are somebody else was also asking this question. Maybe it was you, I think.
It was probably me, because I've been working on this for a while. I've been stuck in the same place for like 2 weeks.
I can spend some time, but Python by itself doesn't have the GUI test aspects, but I wouldn't be surprised if somebody somewhere in the world did something and added a module.
There's a bunch of modules, but a lot of them aren't maintained, and then they haven't been maintained in years, so they don't care.
Or really all you need is 2 clicks here.
I know, right?
Yeah. So if you can somehow get to it, I can spend some time looking at something.
No, it's okay. I don't want to like give you extra work. That is my job, but like.
But
if you
Python by itself, no, I don't. Python by itself is not very.
Because you don't have to use the interface necessarily to be able to find a file with Python, right?
But it's not about just finding the file; it's about giving it to you.
Right. You can't pass that
How
file.
do you tell me how I should talk to you? I should talk to the server using SSH port or Telnet or HTTP or
all that,
what
right?
all that comes into picture, right?
So
Okay.
let's.
So if you know there's modules like that out there that work, but they just haven't been maintained, and there's a project
They
for you.
don't, it's completely a project for me. I found one that's kind of maintained, but I can't get it to work, so that's what I'm gonna be doing right now. Is coming back up here in 2 seconds and going, why doesn't this work?
So I have some more exercises you can try. INI file reader, INI file writer, and a bunch of other things. I also added a slide here for project. Some people, I mean, again, I must have mentioned this earlier. The best way to learn Python is to write code, right, and lots of code. If you're at work, if you happen to have a job and you're working, that's great. What you should do, I think, is go to your boss and say, hey, I'm taking class in Python. Give me something to do in Python, some assignment, some project, something, and hopefully he or she can give you and fight with that project enough until you get better and better. But if you don't have somewhere like work, if you're not working, for example, then it gets actually much harder for you to stay on top of Python. And one way to bridge that is to try something like this. This is a project that it should take you a few weeks, multiple weeks, maybe a few months, 2-3 months type of thing to do all these things. So something to keep you busy, and hopefully as a result through that you're learning Python and doing more things with it. So give it a shot if you want to. So for the next half hour or so, I want to talk about some things about exceptions. I don't think we'll be able to complete it today, but we'll get started and we'll complete it next week. Exceptions. Right? This is another aspect of Python, right? For example, if I open my shell and I said print, or not even print, a equal to 3 plus hello. And I said that. Nothing stops me from typing that and pressing enter, right? What happens then? I'm telling Python to basically add a number and a string and put that into a variable A. Python cannot do that. Python cannot add two different data types. So it throws an error. We call that exception, right? That is what's called an exception. For example, I can quickly type that statement right there on the Python shell. Say a equal to 3 plus hello. See, you got an error. And the rest, this part of the class is about talking about these errors and what you can do with it, what controls you have. In this case, I'm typing and it's saying traceback, and it's saying a special type of error. Not all errors are the same, they're all different types. It's a type error here. Unsupported operand type plus for int and string. In other words, what it's saying is this is an int, this is a string, and plus doesn't know what to do with those two. When there are two different types. That's basically what it's saying. So a type of error, in this case the type of error is type error. And then there's an English sentence about what that error message is. Another example is, let's say I have a list A of 3 elements, and I'm trying to access the 5th element. This is also an error, because A only has 3 elements, I'm trying to access the 5th one is a problem. And now we see the type of error is different. Now it's called index error, and an English message. There are many other types of errors. Syntax error, I'm sure each of you would have run into it at least once in the last few weeks, right? That's another type of error, syntax error. Key error. Let's say if there's a dictionary and you're trying to access the value of a key and the key itself is not present. Let's say B equal to 1:2, 2:3, 3:4, whatever, something like that. And then I say print me B of 56. It says key error. All these are different kinds of errors people may run into. And in this case, it's saying there is no key called 56. The keys that you have are 1, 2, and 3. So what happens when all this what I just showed you is at the shell, as you saw, right? But when you run a code, also you can easily run into that if you put that in a Python code and run it. But what happens is when you don't worry too much about what the text that's on the screen. For example, let's say you have a line of code, like 4 lines of code. 1, 2, 3, 4, 5, 6, 7. And let's say Python hit an exception. I'm going to start calling that hit an exception. Let's say it hit an exception at line number 4 right here. What Python will do is it's not going to quietly go to the next line and start running as if nothing happened. If it hits an exception, it will stop running, and we sometimes call that your program crashed, right? So that's it. After, it's not going to go and continue. So in other words, your program will stop here. And usually when it does on the shell, if you run it in the shell, it will tell you which line number it failed and why it failed, and in English message the type of error. Something useful for you to debug, right? What it also does, by the way, there are certain ways you can handle these errors. You can catch those errors so your program is not crashed. That is called exception handling. Handling those exceptions. That way, the way you will do something like that is there's some syntax you'll see in a minute. You will do something like try, and then you put all your code, these 6 lines of code inside your try block, and then here you'll say except, and then you put some more line here, whatever you want to do. So what this will do is, if the same thing were to happen at line number 4, Python will not crash your program anymore, but it will skip the rest of the code and will go to the handler. This is your handler, exception handler. And then it will go and run the code here. And then after this try block ends and there's some more code here, it will keep running there. So as long as you handle the exception, you're preventing the program from crashing, right? That's what exception handling is about.
So it's like if then else for errors.
Yeah, something like that. But there are certain rules here. You can customize what type of errors you want to handle, what type of errors you don't want to handle, and then accordingly, if it runs into that kind of error, then it handles it, run the handler. If it's not the type you're handling, then it will still crash your program, and so forth. So essentially, you can write an error-tolerant code. I mean, I'm not saying write a bug here and recover it here. But there are certain times where you can hit an exception without your fault. Let's say a good example might be this code, this line here, code is making a call to another function, let's say func1. And that func1 is in a different module or in a different file that a vendor to you gave you, or a customer or somebody. You didn't write that code. You're just making a call to his code. And that guy has a bug. And because of that exception, your program is crashing. Kind of unfair, right? So in such cases, you should really go to that guy and have him fix that bug, or at least understand why it is happening. But in some cases, it just happens, meaning there's nothing you can do. Let's say sometimes user giving a bad input can cause resultant crashes also. So there are cases where legitimately you can't control exceptions, or it's not even a bug per se in the code, but it makes sense to catch them. So you prevent the program altogether from crashing. If you do not have the exception handler, by the way, it will crash. Python will crash your program. Python will throw an exception and boom, done. Which you may want to avoid in some cases, right? So that's what exception handling is about.
Do you paste your whole code in the try loop?
That's a good question. Why not put your entire code in a try block, not loop block, so that your program will never crash?
Slow down.
Right?
What's overhead?
What kind of overhead? Why is that not a bad thing?
Different exceptions.
What is it?
Different handlers, not just one big handler.
Okay, but at the least you are preventing your code from crashing.
I'd rather know how to crash and then fix it.
Yeah, this will print you where it crashed and it will. Yeah, that's somewhat like, sometimes crashing the program is better. Can someone say why? Why you want the program to crash?
The next step may have a dependency.
What's that?
The next step may have a dependency on the first one.
Yeah.
So by crashing it up front, you're not going to the second step. In the end result is the same though. I mean, you're still not giving the user what he wants.
Perhaps the error returned by the system has more details than when you can catch with the handler.
Yeah, yeah. The reason when you want the program to crash is if you are the author and you're testing it. Right? You'd rather have it crash here than crash it in front of your customers. By making the program crash, you can, when the program crashes, you have a lot more debug information. You can know exact line number where it failed, and in some cases, all the inputs to that, it's much easier to debug and fix it. So when you're internally testing it, or you yourself are testing your code, or fellow employees testing your code not the customers, then it's good to have your programs crash. In fact, people go put certain things to force things to crash when some unexpected things happen, so that you want to know about it. When the program crashes, everybody will, the tester or tester, whoever is using, he knows definitely the program is no longer running, it has crashed. So in those cases, crashing is good. When is it not good is, of course, when your customers are using it. Then you want to enable all these handlers. So for some small errors, you don't show him, you just move on. Sometimes the recoveries are good enough. But a good example is in the networking field. You try to talk to yahoo.com and it fails. It doesn't immediately mean your browser, Safari or Chrome, or it immediately doesn't come and say, hey, I can't read yahoo.com. It'll actually try a few times. The moment next to, if you try 15 milliseconds later, sometimes you may get a successful result. So it's okay, the first attempt didn't work, but don't throw the whole thing. Try again a couple more times, and all the time you go through and then move on. So there are some soft errors which you don't want to crash the program for. In those cases, exception handling is also good. So in other words, the recovery, what you do there is retry.
So this is something like if you want to attach, your user must attach a JPEG, but they try to attach another file type, then you can use that and tell them only attach JPEG.
Yeah, but that's not an exception. You can check what they attached, and if it is JPEG, then say don't attach JPEG, whatever it is. But that wouldn't be an exception though. But a high level idea is check for something and do. So the exception handling gives you some control where you don't want the program to crash.
So the difference is, the best practice you're saying is use the exception handling for the final program that is shipped.
At a high level, that's true. But sometimes, let's say if I'm testing Chrome, I'm a QA guy at Google testing Chrome, Yahoo.com, I'm trying to browse, and if I don't get it, even in the testing phases, you don't want to crash the program. Just try again. In fact, it's inbuilt into all the networking protocols, TCP, IP, and everything is try again. So in some cases, but in general, the idea is similar. You want the programs to crash when you yourself are testing it, or your team is testing it, but you don't want your program to crash when your customers are using it.
Or what's the other way called? Like if you're doing the heavy duty debugging inside instead of the try, what would you do? Like to address the errors, how would you have it in the code to address the errors when you're doing the internal?
When it crashes, Python by default prints a lot of stack information. For example, it told you here in my case, right? It told me the line number. Obviously, I'm in the shell, so it'll always be line number 1. But if it's in a file, it'll give me the line number, the function name,
the real error message,
the error message, and why it failed. So this is useful information. And there's other modules also that we look at, something called traceback, that will actually give you even more useful information. So some of the other reasons why you can crash, and there's many more reasons, like you're attempting to open a file that you do not have permissions to open. Let's say if you open and then something, and then the file is there but you don't have permissions to open, Python will crash. You throw an exception. And there's a function that requires 5 arguments and you're supplying 4. I'm assuming the 5th one is not defaulted like we learned earlier. That will, or using a variable without first assigning it to anything. If you just say open your file and say print A, and you have not defined A,
then that will crash the program. You say unknown variable A or whatever. So there are many such examples why exceptions, Python will throw an exception at you. And the general syntax for handling exception goes something like this. You put all your suspect code in the body of try. And when Python runs that code, if it ever, this body can be any number of lines. It can be calls to other functions and any number of lines, right? And if it ever hits, when in that example, in that body, if it ever hits exception type 1, remember there are multiple types of errors, type error, syntax error, IO error, key error, index error, blah, blah. If it's type 1 type of error, one of the type, you can define what that type is. You want Python to run this and block of code. On the other hand, if it's type 2, you want it to run this type of code. And you can have as many types as you want. So depending on the type of error that you ran into, Python will run the corresponding code here after that try. And then you can also add a generic except, which means if it hits any type of error that's not already covered above, then default you run this. And more importantly, it won't crash your program. That's the key thing. And then you can have an else, and finally, which you'll see in a minute. But at a high level, this is how the syntax looks. Any questions on that? Let's look at this example. I'm putting these two lines inside a try, and I have an open file for writing. And then after I open that file, I'm writing some line of text in that file, right? And down here I'm closing it. Except if I hit an IO error, then I don't want the program to crash. Instead, I want to print a relatively useful error message to the user. I'm saying, hey, I cannot find the file or read data from that file. Something like that. So that way, if it never hits IO error when I'm running either of these two lines, it's usually probably to be the first one. IO error usually means the file isn't there, usually. Then I'll hit an IO error and I'll print, instead of saying fail crashing program, I will nicely print a useful error message to the user. Else will run if it did not hit any exception. If it did not hit any exception, which means these two lines ran successfully, then I go to else and I execute these two lines, which is printing a useful error message, useful message. I was able to successfully write to the file, and then I close the file. So that's what else is for. So here's an example where I'm using a specific error handling for IO error. On the other hand, when I'm running these two, and if I hit type error or index error or any of the other kinds of error, then this code will still crash because I'm not writing any handler for those errors. I'm only writing handler for the IO error. And my handler is this one line basically. No, I'm not doing anything fancy. All I'm saying is telling the user something more useful than quietly crashing. That's my error handler. So going back to the syntax, so now we know, so we can have different types of exception handlers. I try some body of code and then accept type 1, then handler for that. Accept type 2, and handler for that, and so forth. And then I got a generic except, which means if any of these two handlers are not meeting it, then it will do this one. You can actually skip both the type 1, type 2, or any of the spell out to put a generic except all the time, which means any exception will be executed, will be handled by the generic handler. And then I got else. Else will run if there is no exception. When I'm running this block of code, if there is no exception, let's say there are 4 lines here, all 4 lines were successfully run, then it will come directly and run else. It's not going to run any of the code in any of the handlers, because there is no exception to begin with, so no handler code needs to be run. Then I'll come to else and run it. And finally is another block. It will run all the time, whether you hit exception or not. That's when else and finally are used. Any questions?
So you have to use like that finally?
This is optional, this is optional. Any of these types are optional. You can have one or more of the types of handlers. You don't have to have more than one. Yeah. But let me ask a question.
For the exception, is after the body, or you can add into the inside the body? Like you have this code, right? So the exception is at the end of the, or you can just add anywhere.
You can handle it. You're saying you can add another try block here inside this body. Is that what you're asking? You can put another try except handler block here also. And then you can have some more code here above, some code below, and another outer level handler. That's fine. So let me ask a question. If finally runs all the time, whether or not you give an exception, what's the difference between a code something like this and try something except all those things, and then putting that finally code, let's say that's block A. Well, if I directly put that in here without using finally, why have finally at all?
Because you may not have an exception, so you have to know what to do if you don't get to any of those.
If there is no exception, let's say, right, then type 1 will not run, type 2 will not run, except will not run, but finally will run. Actually, there is no exception, else will also run, but finally will also run. But if I put that code here, that will also do the same thing.
Is there like the go-to kind of a thing?
There is no go-to statement in Python. Before I give the answer, I want to make sure I would understand the question. What I'm saying is the block A here, that is inside finally, if I put it outside at the same level as try and except, which means the handler completed here, the code block completed here, and then I put the same code here. The difference is this. Let's say I don't have this generic exception, which means there's only type 1 handler and type 2 handler. And let's say I hit, when I'm running, I hit a type 3 handler, right? Which means my handler is not accepting that, is not handling that error, because if this only handles type 1, this only handles type 2, I hit type 3. So my program will crash, right? In that case, finally will run before crashing. Finally, if I have a few lines of code, it will run that code, and then it will crash the program. In other words, your program will still crash, but finally code will have a chance to run before crashing it. Whereas if I put that code here, I mean, assuming this is a type 1 handler or whatever, same as before, and I hit a type 2, I have a type 1 and accept type 2, and then I actually ran into a type 3 error. Again, I don't have a handler for that because I only have type 1 handler and type 2 handler. Now, this program will crash right there where I hit type 3. It's not going to have a chance to run code in block A.
So what would you put in there that you really need to?
Let me get to that in a minute. So in other words, just to say one more time, finally code will run before crashing. Here, the same code, if I position it like this without putting finally, that code will not run. So you'll crash before you get to that. The question, a good example is when you're trying to open a file. If you're not successful in opening the file, you put finally, inside finally, you close the file. So for example, you do something like this. Try, open, and then some file for write mode, let's say, and then accept some error, IO error, let's say, right? Something, I don't know, whatever, some type of error, and then you do something inside that. print an error message, a nice error message to the user, or sometimes retry again, or something like that. Then you put finally, what most people do is you try to close that file. So ft equal to open, you try to close that file. So whether or not you were able to successfully open the file, before you crash, you close it. Because sometimes that's useful, it's a good, being a good citizen. Sometimes these could be network files. And if you don't try to close it nicely, it may cause other problems because the network might be stuck or whatever, I don't know. But it's a good habit to close that file. So that's why you will want to use finally. In both cases, you're going to crash anyway. In this case, you will make an attempt to clean yourself off before crashing. Whereas if you do it like this, you won't have that opportunity. You won't have a chance.
So it's a way to do what they call garbage collection or memory management.
Yeah.
And I'm still not sure what's the difference between the left and the right side. You just have less exception types?
No. I do have the same exception type. I don't have finally here. I have finally here. Finally is another keyword.
But you still have it on the right, so where?
No, I was contrasting between this
and
this.
And the top.
Yeah.
Okay.
This one I'm just showing how to use finally.
Okay. So the idea is just best practice to have some end thing at the end to do memory management, garbage collection, and close anything that's open.
Yep. Okay, so that's about, so here's a little example of how you can handle error, IO error in this case. And if you are not able to successfully open that file, you will instead give a nice error message to the user instead of crashing. In this case, you won't even crash if you actually hit that IO error. If you hit type error or some other error, then you will crash, but otherwise you won't.
Was that the same question she asked as what I just asked? She had something else about.
Yeah, same thing. What would you use it for?
What would you use it for?
Yeah, that's why I was saying you have to closing a file, and then you said memory management, garbage collection. Yeah, all those come under that bucket.
Why would I expect to read data when it's a write open? I mean, your accept IO error message content.
You mean the English message here?
Yeah, that's confusing.
Yeah.
Okay.
Yeah, maybe I should change it now. Because I'm trying to open the file for read purposes.
Well, wouldn't the file get created if it was right? If the file doesn't exist, there was no need to create.
Yeah. Error message, you're giving error message, but not really useful. Huh? It could be erroneous actually. I agree with you. Maybe can't create file is what it should be worded. Right?
Yeah.
The word will create, writing will create. Or I can put read my.
Or do a read.
Yeah, do a read. Matches the.
So in this case, more importantly, your program will not crash. That's the good thing, right? If you didn't have this try exception handling, you will crash. That's the benefit of using
So you'd be better to have finally over there before the closing, right?
What is it?
You would be more benefit to add finally and close.
Yes, it's more benefit to have finally also.
Is there any other way to check for an existence of a file and go ahead? Like
os.path.exists.
Oh, right.
We were talking about that.
Okay.
You can check if the file, that just tells you the path exists or not. It doesn't tell you if you have permissions to it.
Yeah, right.
There may be other permission file like
what I'm trying to get to is like, like for instance in Perl, the same thing would you do like open or die right away.
Yeah.
So that's like just one line, and Python for so long has always used like a concise method of coding. This seems like
no, that's not fully true. Sometimes it's more verbose. Like you have and, or in other languages you have one character or two characters.
Right, but in this example, it looks like the code is like quite a lot for such a small piece of.
No, not just that. It's unfair to compare it that way because you're doing a lot more things. You're giving a nice error message to the user. When it says or die, I don't know what it prints.
And pass a message over there.
Yeah. But you can do more things. You can handle IO error, you can handle type error, you can handle syntax error with all these. And that OR die can, I think, it only handles one type of error, right?
It just doesn't check for exception. It just says if this one fails it.
Yeah, yeah. But here you have a little bit more control about, and it's not just opening. This is just an opening file. This support is for any type of error.
Index.
In this case, I'm opening a file. In another case, I could be looping through a list, or looping through a dictionary, or writing to a database. Anything, it can be any operation, right? The support is a broader support of exception handling, not just for opening files and closing files. So the biggest benefit of exception handling is it allows you to write code that is error tolerant and robust. And you can ensure your program will not crash. So what I'm thinking is it's 3 o'clock. Maybe we'll stop here, we'll resume next week. No, we're not meeting next week, we'll meet the following, 27th. Meanwhile, if you have any questions of any kind, you can email me, continue to email me. So that will be it for today. Did everybody sign here? If not, please do. You can just come by here. So that will be, but I'll be here at 4 o'clock. If you want to try something or anything. Or if you want to take off, you can feel free as well. I'm not going to cover any new material.